So think or you keep this in mind, that we have cryptography in one side and distributed system in another side. Now, digital trust is not automatic, but it must be earned by people and baked into technology. So it requires a robust infrastructure, that is implementing foundational elements like public infrastructure. This is one of the major component or the major aspect of cryptography. Clear data governance, implementing transparent practices for data collection and ethical decision making. So the second 2 points are not based on any computer science theoretical concept. Rather, it deals with data governance and management. Now, let me move on to the blockchain, and I'm going to map the key components of the or the need of a digital trust, and how these this blockchain will help us to have a digital trust. So before going to that, before discussing that, let me define blockchain. Blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat the system. A blockchain is essentially a digital ledger of transactions that is duplicated and distributed across the entire network of computer systems. Each block in the chain contains a number of transactions, and every time a new transaction occurs on the blockchain, a record of that transaction is added onto every participant's ledger. The decentralized database managed by multiple participants is also known as distributed ledger technology. And blockchain is a type of distributed ledger technology in which transactions are recorded with an immutable cryptographic signature. So the basic words that we have to look into is decentralized database managed by multiple participants, or DLT, and immutable cryptographic signature. So these two words are coming under the umbrella of distributed computing and cryptography respectively. Therefore, we know that distributed computing, cryptography are two foundations behind the construction of the blockchain. Now we'll move on further so that we'll look into whether any other theoretical aspect will also help in the development of a blockchain. So this is a panoramic view of a blockchain, distributed ledger of transaction. This is a network of computer systems. We call it as nodes, and everybody is connected so that a sharing of information is there, and it is public. Anyone can inspect the transaction, and that is called as transparency. No single entity control. So there is no centralized control in this in the construction of a blockchain. So the major features of blockchain are sharing, publicly available, ledger of transactions are distributed, anybody can inspect the transaction, and there is no single entity control. So centralized control is not there. Even if the central, so in the case of a centralized control, like database management system, when the centralized server is not working, you will not be able to get the data, or the data availability is not there, which is one of the foundational goal of cryptography. Therefore, in order to remove the control of a central authority, every data or everything will be distributed, or a data replication is there, so that even if the central server fails, you'll be able to access the data. That is one of the features of distributed computing. So the foundation at which the blockchain, the cornerstone in which we develop or will build up a blockchain, we have already seen that distributed computing, cryptography, and game theory. Fundamentally, P2P network, peer-to-peer networks are behind the construction of the blockchain, which doesn't have any centralized control. Cryptographic primitives that we are using in the blockchain are, especially, we have already seen that digital signature is there, hashing is also there. Now, what is the role of game theory? Whenever we want to add a particular block onto the blockchain, we need some mechanism so that, since it is distributed, nobody is there in the control who is responsible for adding the block in the blockchain. For that, we'll look into some game theoretic concepts in the blockchain so that the block can be added onto the blockchain. To be more precise, P2P network is one of the architectural model in the distributed system. There are basically two architectural model in the distributed system. One is the most familiar client-server architecture, and another is the P2P network or peer-to-peer network, which is the foundation stone of the construction of a blockchain. So when a block is added onto the blockchain, this particular entity is shared among various nodes in the peer-to-peer network. The cryptographic hash function and the digital signature is another two functionalities that are present in the construction of the blockchain, which is coming under cryptography. And in order to validate the transaction, we have to solve a puzzle, or the miners or validators should solve a puzzle, and that is done with the help of game theory, which is nothing but the proof of work or proof of stake. Now, what is peer-to-peer? Peer-to-peer is a decentralized network architecture in which participants, called as peers, interact directly with each other without needing a central authority or a server. In a P2P network, each participant acts as both client and a server, enabling them to share resources and services directly with peers. This is one of the architectural that I have already told, that it is one of the architectural model in the distributed systems. And what are the key features of the peer-to-peer network? Decentralization. That is why we have the decentralized architecture. And again, it is a distributed ledger technology. Scalability. Can add multiple nodes into the system. Self-organizing system. Fault tolerance and redundancy, resource sharing, privacy, and security. Now we'll move on to the anatomy of blockchain, how blockchain is constructed. The basic data structure with which we will be developing the blockchain are the block, the chain, and the network. So what is there in the block? A block contains a list of transactions recorded into a ledger over a given period. Size, period, and triggering event for blocks is different for every blockchain. So this is nothing but the transaction, or it is simply recording of data. A transaction, think of a bank transaction. If I have two transactions, either a debiting or a crediting, and that particular transaction will be there in your in your account, and that particular transaction is also recorded in the ledger. So this is similar to a double entry system. Instead of a double entry system, this transaction is stored in a common pool, and that particular transaction can be viewed by the participating nodes in the system. And after adding the transaction in the block, this transaction is validated. How the validation is done or verified? How the verification is done? The verification is done with the help of the digital signature. This transaction is signed, or this transaction is encrypted by the private key of the sender, can be verified by the public key of the sender. That we'll discuss later. So basically, a block contains list of transaction, verified transactions, and that is recorded. And depending on the block size, the number of transactions will be one or more. Now, the next data structure is a chain. This is nothing but a pointer-like structure which will link one block to another. Here, instead of a pointer, we have a hash value. A hash that links one block to another, mathematically chaining them together. This is one of the most difficult concepts in the blockchain to comprehend. It is the magic that glues blockchain together and allows them to create mathematical trust. The hash in the blockchain is created from the data that was from the previous block. This is a fingerprint of the data, and this locks the block in order and time. So whenever we are adding the transaction, it should be in the order of the time. Therefore, there is a chronological ordering is there when we add the transaction into them. And a network is composed of full nodes. You can think it of as a computer running an algorithm that is securing the network, and each node contains a complete node of all transactions that were ever recorded in that blockchain. The nodes are located all over the world and can be operated by anyone. So this is the major structure of the blockchain. Since we are having nodes in the network, we will be adhering on to the layered structure of the computer network. We have the data layer, network layer, upon which we have the presentation layer and the application layer. So in the data layer, for the construction of the blockchain, we have data structure, storage structure, and the ledger pattern. The data structure contains Merkle tree, hash list, digital signature, timestamp, etc. And we have the ledger pattern, which is UTXO, an account, and the storage structure can be a database or any other storage system. Coming over to the upper layer, the network layer, we have the peer-to-peer network, authentication mechanism, and the transmission protocol. Transmission protocol for the TCP/IP, both TCP and IP will be coming on to the network layer. Upon that, we have the presentation layer, wherein which we have the basics of the consensus that is required in the construction of a blockchain. There are two types of consensus. One is proof-based consensus, another is the voting-based consensus. In the proof-based consensus, we have proof of work, proof of stake, and variants of proof of stake are we have the distributed proof of stake, then we have the Ouroboros, etc. All are a form of proof of stake. So when you look into proof of stake, it depends on how much resources are available for a particular validator or a miner, so that that particular node can add a block into the blockchain. So DPoS is delegated proof of stake. EPOS is effective proof of stake. Ouroboros is a provable proof of stake. Then we have proof of elapsed work and luck, which is a lightweight proof of stake. And coming to the voting based consensus, we have our PBFT, which is Byzantine fault tolerance, practical Byzantine fault tolerance. Every voting based consensus is based on Byzantine fault tolerance mechanism. And Byzantine fault tolerance mechanism is one of the concept behind the distributed system. The distributed system do have some mechanism for electing a leader and having a consensus with the choice, or with the what to say, with the opinion of the leader, so that there will be a voting based consensus. And always remember that there will be honest leaders and dishonest leaders. So in that particular scenario, how to tackle or how to get maximum vote, or how to have an honest decision, and that can be done with the help of Byzantine fault tolerance. And in the distributed system, there is a problem called Byzantine general problem, and there are a lot of algorithms to solve Byzantine general problem, and that is what is used in the construction of a consensus layer in the blockchain, which is based on voting. And upon that, we have the contract layer, because blockchain is used for the development of cryptocurrencies as well as smart contract. And for that, we need certain languages like Solidity, Viper, etc. And the contract code can be a bytecode, chain code, etc. And we have our Ethereum virtual machine, which is the executable platform, Docker 3, WebAssembly 3, etc. These are some executable platform of the contract contract layer of the blockchain mechanism. Upon that, we have our cryptocurrencies, blockchain in healthcare, blockchain in Internet of Things, blockchain. These are some of the use cases of the blockchain. Blockchain in energy, then non-fungible NFTs called as non-fungible tokens. Non-fungible tokens are nothing but the resource which is having a unique ID, which cannot be transferred to another, even if you have the a similar kind of tokens. So the unique identity will prevent you in interchanging or in exchanging the token to another person. So this is non-fungible token is only a unique identity which is not transferable, or it is not possible to. So that is where the security lies in. It is not possible, or you will not be able to mimic this particular token, even if similar kind of token is there, because it is having a unique identity. So we'll explore more in the more details of this particular layering architecture. So we'll move on to that. So this is the block structure. Just look into this block structure. A block is having a header. That's the block version. And for the chaining, there is a hash from the parent block, and the next block is linking with the help of the hash of the current block. This is how the chaining is done, or this is how different blocks are glued together. Apart from that, we have a timestamp of the creation so that this will help to verify whether there is any tampering done. One of the mechanism. Then the next two things, or the next two fields are nonce and n bits. Nonce is a particular value that will help in the verification of blockchain when miners are trying to solve the puzzle, and n bits are helping you to find the difficulty to verify or to validate this particular block and add to the blockchain by a miner. Then we have a Merkle tree root. Merkle tree is a data structure that is used for the construction of the blockchain. And what is a Merkle tree? That is the next thing that we'll be looking into. We have a number of transactions. Each transaction is validated by a digital signature, and this digital signature will be having a hashing function. And when you have two transactions, each transaction is hashed, and the hash value of each transaction is taken. And those two hash values are taken together, and we'll be having another hash function. So depending on the transaction, we'll be creating a tree-like structure from the bottom transaction and the root of the transaction. And the basic structure is called as the Merkle tree, and the root of the Merkle tree is called as the Merkle tree root hash. Along with that, we have a transaction counter in the block body. So this is the basic block structure anatomy. Hope it was clear to you. Hello?
Yes, ma'am. Yes, ma'am.
Am I audible to you?
Yes, ma'am. You are audible.
Okay. So we shall proceed. Now, this is the description of the block header. Block header is the metadata part of the block and includes the following field: the previous block hash, which is a unique identifier of the preceding block in the chain, which cryptographically links the blocks together. Timestamp, record the time when block was created or added to the blockchain. Merkle root is a single hash that summarizes all the transactions included in the block and allows for the efficient verification of all transactions in the block. Nonce, the number used one, that is changed by the miners to solve cryptographic puzzles, ensuring the block's hash meet the required difficulty target for mining. Version indicates the version of the blockchain protocol, and the difficult target will help the miner to check whether the threshold is met or not. Whether the miner should use most of the computing power to find the value in such a way that the value should be less than. That is one of the puzzle that the miners need to solve in proof of work, and which should be less than the value of the hash. And with the help of the nonce only, the other people will be checking whether the miner succeeded or not. So that is why the two values, that is the nonce and the difficult target, which is specified as n bits, are given in the block header. Now, the block body contains transactions and transaction counter. The main data within the block is the transaction, which is hashed and validated. Now, how they are connecting? The block is chaining with the help of the previous hash, and the next block is connected with the help of the hash of the current block. Now, the security of the blockchain is depending on the hash value of the previous block and the hash value of the current block. The current block contains, or the current block hash value contains the hash value of the previous block. So even if a change in the current block or the previous block is there, then the hash value of the current block will be changing. Therefore, will be changing in a very, very huge way, in such a way that, or it is called as avalanche effect. And since there is an avalanche effect, it is possible to find that a tampering occurred in the block or in the chain. Therefore, this is how the tamper proof is done in the blockchain. A hash chain storage. So we'll, after block construction, we'll be moving on to our cryptographic primitive called hashing. Hash pointer and Merkle tree are the two fundamental building blocks for implementing the blockchain in Bitcoin using hash chain storage. Need not be always the Bitcoin. Wherever we are trying to construct a blockchain, we need to have the hashing. And hash pointer is the hash of data by cryptography pointing to the location in which data is stored. A hash pointer can be used to check whether or not a data has been tampered. A blockchain is organized using hash pointers to link data blocks together. And with a hash pointer pointing to the predecessor block, each block indicates the address where data of the predecessor block is stored. The hash of the stored data can be publicly verified by the users to prove that the stored data has not been tampered. Now, why hashing is so powerful? A hash function, it is a function. Therefore, a hash function is a mathematical function that takes an input string of any length, converts it into a fixed length output string. This fixed length output is also known as hash value. To be cryptographically secure and useful, the hash function should have the following properties. One is collision resistant. Given two images, M1 and M2, it is difficult to find a hash value such that hash of KM1 is equal to hash of KM2, where K is the key value. No two messages should have the same hash value. Then, pre-image resistant. Given a hash value H, it is difficult to find a message M such that H is equal to hash of KM. So even if a hash value is given, it is not possible to find M. Second, pre-image resistance. Given M1, it is difficult to find another message M2 such that hash of KM1 is equal to hash of KM2. Then, so in order to prevent the collision, you need to have a large output space. Otherwise, if the output space is small, then it is possible to find many things. Deterministic, a hash function must be deterministic. which means that for any given input, a hash function must give the same result always. Avalanche effect, a small change in the input should drastically change the output. Puzzle friendliness, this means even if one gets to know the first 200 bytes, it should not able to determine another 56 bytes if the hash value is 256. Now, why it is given us that? Normally, SHA-256 is used as the hash function. That is why it is. I have written this as, even if first 200 bytes are known, next 56 byte cannot be determined. Fixed length mapping, for an input of fixed length, the hash function will always generate the output of the same length. Now, what are the various hash functions used? Different classes of hash functions are used. Race, integrity, primitive, evaluation message digest, includes RIPMD, RIPMD 128, 160. These are the key sizes, 256, etc. Out of which RIPMD 160 is the most common one. And this is based on message MD4, message digest 4 version. And RIPMD 256 and 320 have fewer chances of accidental collision, but do not have higher level of security as compared to RIPMD 128 and RIPMD 160. Now, nowadays this is not used because in the case of a Bitcoin, there is a problem, or there is an attack on this particular race hash function. Now, the next is the message digest family, MD2, MD4, MD5, MD6, etc. Most commonly used message digest is MD5, which is used to generate 128-bit digest from 512 bits broken down into 16 words composed of 32-bit each. And it is Ronald Rivers designed the algorithm in 1991 to use a digital signature verification. But this is no longer considered as a cryptographically secure method and is not used for cryptographic authentication now. Then Whirlpool, again another cryptographic hash function described in 2000, which is a modified version of AES, Advanced Encryption Standard, and it produces a hash of 512 bits. The most commonly used hash function is the family of SHA, comprises of SHA-0, SHA-1, SHA-2, SHA-3, and SHA-0 is 160-bit hash function published by the NIST in 1993. Then 1995, SHA-1 is designed to correct the weaknesses, and in 2005, the method was found to uncover collisions in SHA-1, and that is there in SHA-1. Then SHA-2 is the variant following, but now we are using 256. In 2012, KCAC algorithm was shown as new SHA-3 standard, and this is used in the construction of the Ethereum ecosystem. Now, SHA-256 is used and is developed by National Security Agency in 2001. Now, how SHA-256 is working? SHA-256 operates by taking an input and processing it through series of mathematical operations. The algorithm divides the input into blocks of 512 bits, each processed in 64-round operation. The operations include bitwise logical functions like AND, OR, XOR, as well as bitwise rotation. The major steps in SHA-256 are data pre-processing. Input data is padded and extended to ensure that it is a multiple of 512 bits in length by adding one bit followed by zeros and then appending the length of the original message in bits. Then message expansion. 512-bit input block is divided into 16 32-bit words, then expanded into 64 32-bit words through series of logic operations. Then the expanded 64-bit message block is processed through a series of 64 rounds, each involving the determination of a round constant, so that unique 32-bit constant value is generated based on the position in the sequence. Then calculate the message schedule. 64 entry message schedule is generated based on 64 word message block and round constant. Then update the working variables. The working variables, which are 8 32-bit words that store intermediate values during hashing process and updated based on message schedule and set of logical operation. After that, the hash value is computed finally with a 256-bit length. Now, where these hash functions are used in the blockchain. The hash functions are used in the blockchain in different areas. I have already told you that the hash function is used to create the Merkle tree, so that it is infeasible to find two Merkle trees with same root hash, which protect the integrity of the block header by storing the root hash within the block header. Then, in proof of work, to validate the block structure, so that the one who add the blockchain will solve the puzzle, so that the block header whose hash value should be less than the threshold value. So that particular threshold value should be looked into and will check with the help of the nonce and the n bit. The digital signature, all digital signatures will be having or will be using the hash function for signing a particular message, and the hash function is a vital part of the digital signature. Why? Because it must ensure the integrity of the message. Then chaining of the blocks. Each block header in the block contains two hash value. One is the hash value of the previous block and another contains the Merkle root hash, and then the hash value of the current block also. So modifying one block requires generating new versions of every following block, which is again a difficult thing, and it is very difficult, so that there is an avalanche effect when there is a small change in the hash value of the previous block. Therefore, tamper proofing can be ensured by the help of the chain of block hashes. Now, why proofing? Hello? Why it is tamper-proof? If an adversary or an attacker attempts to change data in a block in entire chain in order to disguise the tampering, the adversary has to change the hash pointers of all previous blocks. The adversary has to stop tampering because he will not be able to falsify the data on the head of chain, which is initially generated once the system has been built. And this opening block in the chain is called as the genesis block. Finally, the adversary's tampering will be uncovered because by recording this single root hash pointer of the genesis block, one can effectively make the entire chain having the property of tamper resilient. Users are allowed to go back to some special block and verify it from the beginning of the chain. Now, the Merkle tree. Merkle tree is defined as a binary tree with its tree nodes linked to one another using hash pointers. In turn, grouping these nodes into disjoint groups such that each time two nodes at lower level are grouped into one at the parent level. And for each pair of lower level nodes, the Merkle tree construction algorithm is creating a new data node which contains the hash value of each. This process is repeated until reaching the root of the tree. The Merkle tree has the ability of preventing the data from tampering by traversing down through hash pointers to any node in the tree. So this is a particular construction of the Merkle tree. There are transaction T1 and T2. The hash of T1 and hash of T2 is hashed together to form hash 1, 2. Hash of T3 and hash of T4 is merged together as hash of 3, 4. And hash of 1, 2 and hash of 3, 4 is again hashed together to form hash of 1, 2, 3, 4, which is acting as the Merkle root. Excuse me. So this is how the Merkle tree is constructed. Tamper resilience. Even if the adversary or an attacker tries to tamper with the data at the leaf node, it will cause a change in the hash value of its parent node. Even if he continues to tamper with the upper node, he needs to change all nodes on the path from bottom to top. One can easily detect the data has been tampered with since hash pointer of the root node does not match with the hash pointer that has been stored. So the advantage of the Merkle tree is that it can prove effectively and concisely the membership of the data node by showing this data node and all its ancestor node on its upward pathway to the root. The membership of the Merkle tree can be verified in logarithmic time by computing the hashes on the path and checking the hash value against them. Now, how will you create the block and add the block onto the blockchain? So we have created the block, we have verified the block. So and validated the block. Now, how will we add the block in the blockchain? That is the next question that we are going to answer. So block is created and validated with the validated transactions, and we have the previous block hashes also there to link the value to the root to the blockchain. Now, in order to add the blockchain into the in order to add the new block to the blockchain, there should be consensus mechanism, because we are having the peer-to-peer network. Nobody is responsible. Therefore, somebody should say that this block is verified and this can be added onto the chain. How it is possible? So for that, we'll be moving on to the consensus mechanism. There are different types of consensus mechanism. One is by having the proof of stake, etc., where the network nodes verify the validity, or we can have the voting based mechanism like practical Byzantine fault tolerance mechanism. So once consensus is reached, the block is permanently added to the existing blockchain and become the immutable part of the shared distributed ledger. Why it is immutable? Because it is having a the hash of the previous block, and whenever there is some distraction or some break is there, then the entire blockchain seems to be tampered, and that can be verified easily. Now, the property of all the cryptography cryptographical primitives that are used in the blockchain is in such a way that the verification can be easily done. But similar type of construction cannot be done or cannot be forced or cannot be mimicked. That is why it is called as immutable part of the shared distributed ledger. So, how the block is created? Transaction is initiated, and this transaction is stored in the block. And when the transaction is initiated, the transaction is broadcast to the network of node, and the transaction is verified by the digital signature verification for the authenticity of the transaction, and the validated transactions are grouped together into a new block. And once the block is created, the timestamp, the nonce, and the hash of the previous block is also placed in the block, and the cryptographic or the digital fingerprint of the current block is also constructed. After that, the new block is distributed across the network, and the nodes participating in the consensus mechanism should agree with the validity of the block. And that is done with the help of proof of work, proof of stake, etc. In the proof of work, miners compete to solve complex mathematical puzzle. In the proof of stake, validators are chosen based on the cryptocurrency they have staked. So with the help of this mechanism, the validity of the block is checked, and once consensus is reached and the validators or the miners approve the block, it is permanently added to the end of the blockchain, which is the longest chain. This process links the new block to previous one via its hash, creating an immutable and secure chain of blocks. Now, what is proof of work? Proof of work consensus is the mechanism of choice for the majorities of the cryptocurrencies currently in circulation. The algorithm is used to verify the transaction, create a new block in the blockchain. And this is coined by Cynthia Dwork and Mani Nair. They are the famous cryptographers, and later this is applied by Satoshi Nakamoto in the Bitcoin paper in 2008. We don't know who Satoshi Nakamoto is. With the name of Satoshi Nakamoto, he published the paper or the white paper of Bitcoin is published in 2008. And the proof of work was used by Marcus Jacobson and Ari Jewels. Again, they are the famous cryptographers in a publication in 1999. Cryptocurrencies like Litecoin, Bitcoin are using proof of work. Ethereum was using proof of work, but now shifted on to the proof of stake. We'll discuss that. Now, the purpose of the consensus mechanism is to bring all nodes in the agreement, that is, trust one another in the environment where nodes doesn't trust each other. All the transactions in the new block are then validated, and the new block is then added to the blockchain. The block will be adding to the chain which has the longest block height. Miners, they are special computers on the network, perform computation work in solving complex mathematical problem to add the block to the network. So since lot of computation work is done for solving the complex mathematical puzzle, it is named as proof of work. Now, the main features of this proof of work is it is hard to find a solution for the mathematical problem, but easy to verify the correctness of the solution. Say, for example, the miner should find a particular threshold value which is almost similar to the nonce in such a way that it should be less than the value of the hash of a particular block. So there is a value of the hash block and value of nonce. This is not known to the miners. Therefore, the miner need to randomly check or take the values randomly and check whether it is almost approaching or almost approximately equal to the nonce, which is similar to which is approximately equal to the difficulty of hardness, which is specified in the n bits of the block, so that it should be lesser than the value of the hash. If when the number is very large, random checking will take a large amount of time. That is why it is said or it is assumed that as it is hard to find the solution. But nonce and the n bits are available so that the verification is easy, or the signature, creation of the signature is difficult, but the verification is easy. Similar to that, the verification of the value, the hash value is not. Using the nonce and the n bits, we will be checking whether the value is less than the hash value. The verification is easy. Therefore, correctness of the solution is can be verified by other participant nodes, and the participant who found the solution is considered as the winner, and he will be having he'll be getting some rewards by creating some bitcoins in the Bitcoin scenario. So how proof of work consensus work? Verifying the transaction through mining process, and the proof of work consensus algorithm involves solving a computationally challenging puzzle in order to create the new block in the Bitcoin blockchain. The process is known as mining, and the nodes in the network that engage in the mining are called miners. The incentive for mining transaction lies in economic payoffs, where competing miners are rewarded with 6.25 Bitcoins and a small transaction fee. This reward will get reduced by half its current value with time. And a huge amount of energy and time should be consumed in mining. The process of verification of transaction in the block to be added, organizing these transactions in the chronological order in the block, and announcing the newly mined block to the entire network does not take much energy and time. The energy consuming part is the solution of the hard mathematical problem for linking the new block to the last block of the blockchain. When miner finally finds the value, he broadcasts the value to the whole network, and then he will be getting the reward provided by the proof of work. Currently, mining a block in the Bitcoin network gives the winning miner 6.25 Bitcoins. The amount of Bitcoins won half every 4 years. So the next deduction in the amount of the Bitcoin is due to at around 2024 with the current rate and growth. More miners coming, with more miners comes the inevitability of the time it takes to mine new block getting shorter. So this means that new blocks are found faster in order to consistently find one block every 10 minutes. That is the amount of time that the Bitcoin developers think is necessary for a steady and diminishing flow of new coins until the maximum number of 21 million is reached. So the Bitcoin network regularly changes the difficulty level of mining a new block. That is why nonce will be changed timely or regularly, so that the difficulty level of mining can be changed. So this uses Hashcash proof of work system as mining basis. The hard mathematical problem can be written in the abstract way as: given a data A, find a number x such that hash of x appended to A result a number less than B. So data A is given. You have to find a number in such a way that hash of x appended to A will be having a number less than B. The miners bundle up a group of transactions into block and try to mine. To mine it, a hard mathematical problem has to be solved. This problem is called proof of work problem, which has to be solved to show that miners has to do some work in finding the solution to the problem. And the answer to the problem needs to be a lower number than the hash of the block for it should be accepted, which is known as the target hash. A target hash is a number that the header of the hash block must be equal to or less than for a new block, along with the reward to be awarded to the miner. Lower target, the more difficulty to generate the block. Miner continues testing different unique value known as nonce until a suitable one is produced. The miner who manages to solve the problem gets the Bitcoin reward and add the block to the blockchain by broadcasting that block has to be mined. The common cryptographic protocols for proof of consensus is based on SHA-256. And others include Script SHA-3, Script Jane, Script N, etc. Challenges: the 51% risk. If controlling entity owns 51% or more than 51% of the nodes in the network, the entity can corrupt the blockchain. Time consuming. Miners have to check over many nonce values to find the right solution to the puzzle. Resource consumption. Miners consume high amount of computing power in order to find the solution to the hard mathematical puzzle, which leads to wastage of precious resources like money, energy, etc. Not an instantaneous transaction. Confirmation takes 10 to 60 minutes. When you work with the Ethereum and Hyperledger Fabric also, in order to add a small block in the blockchain, in the Ethereum, it may take 10 minutes, but to have a contract with the help of the Hyperledger Fabric, it may take, a very small contract may take 30 minutes. Proof of stake. Again, another consensus mechanism where network participants or validators lock up their cryptocurrency holding, which is called as a stake, to be eligible to validate new transaction and create new blocks. Unlike proof of work, it doesn't rely on the computational power. Rather, they randomly select a validator to add block to the chain, incentivizing honest behavior through rewards and promoting energy efficiency and scalability. Proof of work have staking. The participant lock a certain amount of cryptocurrency as collateral to become potential validator. An algorithm selects a validator from the from the pool of stakers, and the probability of being chosen proportional to their stake amount. Then the validation. The selected validator verifies and adds the transaction, and the validator receives reward, usually in the form of cryptocurrency, for their service only. They can't create a new Bitcoin in proof of stake. Advantages: energy efficiency, reduced environmental impact, scalability, and security. Disadvantages: centralization risk, high entry cost to become the validator, and nothing at stake problem. In the proof of stake variation, validators have no financial downside for supporting multiple forks of blockchain, potentially undermining security. Examples: Ethereum, Cardano, and Cosmos. They are using the proof of stake for the validation. So this is the comparison between proof of work and proof of stake. In the proof of work, participant nodes are called miners. As the proof of stake, they are called validators or forgers. Mining capacity depends on computational power in proof of work. Validating depends on the stake value, the amount of cryptocurrency they are holding. Mining produces new coin in proof of work. No new coins are formed in proof of stake. Miners receive block rewards. Validators receive only transaction fees. Massive energy consumption in proof of work. Energy consumption is less, prone to 51% attack. 51% attack is not possible in proof of stake. Now, the consensus based on voting, the Byzantine fault tolerance, it is a feature of a distributed network to reach the consensus even when some nodes in the network fail to respond or respond with incorrect information. The objective of Byzantine fault tolerance mechanism is to safeguard against system failure by employing collective decision making, which aims to reduce the influence of faulty nodes. It is derived from Byzantine general problem. So this refers to a system's ability to function correctly and reach consensus even if some of its components fail or behave maliciously. So in the context of blockchain, consensus, this consensus algorithm enables a distributed network of nodes to reach an agreement on the validity of transaction and maintain integrity of the blockchain even in the face of malicious attack or system failure. The Byzantine fault tolerance designed to prevent Byzantine general problem, a theoretical scenario in which group of generals must coordinate an attack on the city, but some of the generals are traitors who send false information to others. And there comes the game theory. The game theory solutions comes over here. In the blockchain network, the Byzantine general problem can manifest as nodes on the network that behaves maliciously or fail to communicate correctly. So traditionally, 2/3 of the total number of nodes are agreeing on to the validity of the transaction, then that particular block is added onto the blockchain. Otherwise, the block is rejected. Drawback is a higher level of trust in the network participants should be there. A significant percent of the nodes may behaves maliciously or fail to communicate, then the network will not be able to add the block into the blockchain, or it is not possible to reach the consensus and maintain the integrity of the blockchain. But this Byzantine fault tolerance problem is used in the private or enterprise blockchain. There are three types of blockchain are there: public blockchain, private blockchain, and there is a hybrid of these two blockchain are also there. So in the case of a private blockchain, this is okay, but in the case of public blockchain, this particular mechanism of consensus is not easy to achieve. So we'll be moving on to the proof of stake or proof of work type of consensus. PBFT is normally used in most of the private blockchain, practical Byzantine fault tolerance. This work by breaking down the consensus process into series of steps that are repeated for each transaction. Each step involves different node in the network, and each node is responsible for verifying the validity of the transaction before passing on to the next node. This requires certain number of nodes to reach a consensus on the validity of the transaction before it is added on to the blockchain. And the PBFT, the maximum number of the faulty node should be n-1/3. That is, 1/3 can be less than 1/3 can be faulty. Greater than 2/3 of the nodes agree with the value, then the block is added on to the blockchain. The benefit of PBFT is that high throughput and low latency, even when the network having large number of nodes. And this is also known to have high level of security, as it can tolerate up to n-1/3 faulty nodes without compromising the integrity. Drawback: certain number of nodes to reach the consensus may not be suitable, or this is not suitable for smaller networks, because n-1/3 will be very huge in the case of small network. Therefore, This is not suitable for having nodes with smaller numbers. Now, I'll give you a case study, the Ethereum ecosystem. The ecosystem of the Ethereum blockchain comprises of several integral components, which operates on the decentralized peer-to-peer network. Apart from this, there is a special Ethereum client called Geth that functions on the node and establishes connection to the peer-to-peer Ethereum network, facilitating the download and local storage of the blockchain. You see the diagram. The Ethereum client is known as Geth, who is responsible for communicating with the nodes, and this Geth is communicating with distributed app users of mobile devices, desktop, etc. Ethereum client via Geth, Ethereum smart contract developers, wallet users with the help of W3.js, Web3 JavaScript, with the help of the remote procedure called JSON RPC. So the communication is done with the help of the JavaScript and the JSON RPC to the Ethereum client, which is called as Geth. So Geth is responsible for communicating with other Ethereum client nodes or miners. So the components of Ethereum ecosystem are keys and addresses, accounts, transaction, messages, Ether. Ether is a cryptocurrency, tokens, and the Ethereum virtual machine, which is coming under the contract layer. The Ethereum blockchain keys and addresses serve the purpose of denoting the ownership and facilitating the transfer of Ether. These keys consist of pairs comprising of private key and public key. Private key is generated randomly, remain confidential. Public key is derived from the private key. Addresses with 20 byte codes are generated from the public key are utilized to identify the accounts. So since there is a key pair, the cryptography is asymmetric cryptography, wherein which digital signatures can be generated with the help of the private key of the sender and verified by the public key of the receiver. For the generation of the key, the private key is randomly selected in accordance with some specification, because the public key private key pair should have some relation, then only the verification can be done. But when the public key is known, the private key should not be obtained. Therefore, some hard assumption should be there, and that is done with the help of a special elliptic curve, which is called as SCCP 256K1. And the digital signature used is the elliptic curve digital signature algorithm for the recovery function, and the address is generated from the public key, specifically from the last 160 bit of KECAC hash, which is a variant of SHA. The account serves as the fundamental components of Ethereum blockchain, consist of pairs of public-private keys. Users utilize account to engage with the blockchain through transaction. Prior to submitting the transaction to the network via a node, it is digitally signed, and the transaction-driven state machine will find the state of the Ethereum is established and modified through interaction between the accounts and execution of the transaction. State transition. Each account within the Ethereum network possesses a state that when aggregated reflects the overall condition of the network. The state of the Ethereum network is refreshed with each new block added. Action executed between and on these accounts signifies state transition. The transition is facilitated by state transition function, which operates as follows. The validity of the transaction is confirmed through checks on syntax, signature and signature authenticity and nonce. The transaction fee is determined and the sender's address is identified via the signature. The sender's account balance is verified and adjusted accordingly, with the nonce being incremented. Sufficient either must be provided to cover the transaction cost, and that is calculated per byte and increased proportionally with the transaction size. So this step involves the actual transfer of value moving from sender's account to the recipient account. If the specified destination account does not exist, it creates automatically. In the instance where transaction failed due to insufficient balance or gas is the amount that we have to have for the transaction, all state modification are reverted except the fee payment, which is allocated to the miners. Ultimately, any remaining fee is returned to the sender as change, and the fee is distributed to the miners accordingly. At this stage, the function yields the resulting state, which is also recorded onto the blockchain. There are two categories of account: externally owned account and contract account. Externally owned account is similar to the Bitcoin account, which is being governed by the private key. Contract account are distinguished by their association with the executable code in addition to the private key. So there are key features, and the transactions are categorized into two: message call transaction, which facilitate the transmission of messages between contract account without creating new account. Contract creation transaction. This transaction results in the formation of new contract account. Successful execution of each transaction leads to the creation of an account that is associated with a particular code. Now, both the transaction consist of several fields, and the fields are nonce. Nonce is already there for having the consensus. Nonce is a sequential number that increases by 1 with each transaction initiated by the sender. And the gas price field indicates the amount of V. V is the smallest value of the coin, with the value of the amount of, or the coin in the ether is called as the Bitcoin of Ethereum is called as ether. V is the smallest form of unit of ether, small unit of ether, and this gives a unit. This fee is applied per unit of gas, and there is a maximum amount of gas that can be utilized for the execution of the transaction. Let me move on to the use cases of blockchain in the government sector: voting, proposition, P2P bond, etc. for digitizing the document, contracts, etc. Then in the health, tracking medical credentials, electronic health records, drug traceability, etc. In IoT, personalized drones, digital assistants, etc. Personalized robots, smart home networks. Then in education, storage of permanent records, learner identity verification and information security, student ownership, intellectual property protection. In financial industry, we have the digital currency payment, decartelized capital market on blockchain, clearing trading derivatives, bookkeeping, etc. So by that, I think I'll wind up for the time being, so that you can ask some questions accordingly. If you have any questions, I'm ready to clear that.
Dr. Preetham Matthew K. Professor, madam?
Yes.
I'm Dr. Ganapathy, professor actually. Very nice actually, all the basics of thing you have covered. Digital signature as well as...
Thank you so much.
Actually, I'm having 2-3 questions with you actually.
Okay.
That is, now Government of India has created national the blockchain framework. Madam may be aware of that actually. Am I right, madam? National
What
Blockchain framework by MIT.
basically now the blockchain framework can be developed either using mostly using the Ethereum framework. Okay, right?
No, I want to know, for example, you have given use cases,
Yeah.
supply chain,
See,
health sector,
correct.
financial sector, everything. How much it is secured, whether it is proved in e-governance applications. That's why I want to know. Because in foreign
Definitely.
countries, they are using so much. In India, whether it is there, yes, the technology is very new to us actually.
See,
In banking sector, yes, are you any idea on that, please?
in the current scenario, with the use of the Ethereum, currently normally the people are using the Ethereum framework for developing the blockchain, right?
Fine. Fantastic.
Right. So that is the only framework available so far. But creating a block and adding a block onto the blockchain
Yes.
do take a huge amount of time.
Okay.
Okay, so practically, it takes a lot of resources and time consuming.
Okay.
So there is no, as of my information, there is no effective framework for the
Okay.
timing for small applications like storing the educational work, etc. It is very difficult to store the huge amount of data within a limited period of time. That is
Okay.
not possible with the currently existing framework. That is why I told you that we can the research is open, right?
Okay.
So as to create an efficient, so as to add a block onto the blockchain efficiently without taking much time. Okay.
Okay.
Right.
Okay. Thank you. But
Thank
digital signature, most of the e-government applications they are using it actually.
Digital signature is used for giving the verification and validity of the particular message. And here the message is the transaction.
Yes, ma'am.
Okay.
Thank you, Professor. Thank you.
Any more queries?
Any example of Ethereum? I was, let me check with the chat. Any examples of Ethereum smart contract, including creating digital tokens? Normally, digital tokens are developed. Smart contracts are normally created using Hyperledger Fabric. And the thing is that what I have encountered is that when we try to create a smart contract, now for a very small contract itself, the Hyperledger Fabric is taking about 30 minutes, right? So everything is in the research level. I don't know whether it is coming onto the practical level with using a limited time or within a small period of time, because time is very very expensive, right? Our time, we can't spend much time to create a smart contract. Rather, we'll be moving on to the contracts in some other digitalized way. So we have to find some mechanism to make the smart contract within a small, shorter span of time.
Okay, thank you. Now we can officially wind up this session. Good afternoon, everyone. On behalf of the Department of Computer Applications, MES College, Maramballi, I sincerely thank Dr. Preetha Matthew ma'am for today's enlightening session on blockchain, building trust in the digital world. Ma'am, We have clearly explained how digital trust is built through strong infrastructure, transparency, and ethics, and how the blockchain, with its immutable ledger, distributed computing, and cryptography, plays a vital role in ensuring trust. Your insights on the anatomy of blockchain, key components like blocks, hash values, consensus mechanism, and smart contracts, along with its application in cryptocurrencies, have given us a clear and practical understanding of this transformative technology. We are truly grateful for sharing your expertise with us. And on behalf of everyone, thank you once again, ma'am. Thank you.
Thank you so much.
Thus, we come to the end of today's first session. Starting shortly, we will move on to the next session. We will go for a 5 minute short break.
Thank you. All the best to every participants. Hope this is an informative session for you. I think you'll be benefited by this. Thank you so much.
Thank you, ma'am.
Thank you.
Hope I'm audible.
Yes.
Okay, thank you. Welcome, CB sir.
Yes, ma'am. Audible.
Good, yes, ma'am.
Okay, sir. Welcome back, everyone. I hope you all had a refreshing break and are ready to dive in. Let's move on to our next exciting session of 6-day online adult faculty development program on securing the future, cybersecurity, forensics, and the world of blockchain, hosted by the Department of Computer Applications, MES College, Maribale. It's my privilege to introduce the speaker of this session, Mr. C.P. Matthew George, a SysOps engineer and cybersecurity enthusiast with extensive experience in cloud platforms, IT operations, and advanced security practices. Currently with Enough Information Technologies Private Limited, Mr. C.P. Matthew George manages enterprise IT infrastructure across Azure, AWS, and GCP, handling cloud deployments, Kubernetes, virtualized environments, and secure file transfers. He has a unique dual specialization in system administration and cybersecurity, which has enabled him to successfully defend against real-time cyber attacks, design and execute internal phishing simulations, configure firewalls and VPNs, and continuously monitor emerging threats to protect critical systems. His experience spanned both red and blue team operations, from offensive security exercises that simulate attacks to defensive strategies that safeguard organizational assets. Previously, he has trained aspiring IT professionals as a Red Hat certified system administrator and engineer, covering Linux and Windows Server administration, web servers like Nginx and Apache, and virtualization platforms such as KVM. Alongside his professional commitments, he actively engages in offensive security challenges such as capture the flag competitions and platforms like TryHackMe, reflecting his great passion for hands-on learning and staying ahead of evolving threats. With his deep experience in both offensive and defensive cybersecurity, today he will guide us through the dynamics of cyber warfare in his session, A Tale of Two Teams, Red versus Blue in the Age of Ransomware. Dear participants, please join me in giving a warm welcome to Mr. C.B. Matthew George. Over to you, sir.
Thank you, Bismin. That's a wonderful introduction for me. And hi all, good afternoon. So let me share my screen.
Good afternoon, sir.
Okay, I hope my screen is visible.
Yeah, now it's visible, sir.
Okay. 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 So today we're gonna discuss regarding the two teams, that is red and blue, in a scenario that's ransomware. Okay. So I believe like you guys have gone through like the ethical hacking lifecycle and things like that. Yes.
Yes.
Thanks for the response. I think we should. I highly appreciate if you guys could respond. Yeah. Okay. So ransomware kind of like it follows the same pattern. So the ransomware attackers kind of like do the same steps that we have kind of learned earlier in the ethical hacking lifecycle. So before moving to that, let me once again introduce myself. My name is C.P. Matthew George. I'm currently working as a SysOps engineer at INAP. And I do have like background, like I have worked in various kind of cloud administrations and also the on-premise server administration and the networking side as well. I'm passionate and I'm a huge enthusiast of cybersecurity. So that's what brought me here. So that's my kind of a small introduction. Anyway, like before moving on, like have you guys noted anything today? Anything kind of like related to the internet? Any anniversary or something like that? Anybody can tell? What's today's specialty? Anyone? No one? Well, if you kind of like go to your search engine, Google, the doodle, the Google logo is kind of different, right? If anyone's kind of like attending with the PC, I believe most of you are. So it's actually like, yeah. It's Google's 27th birthday today, actually. So that's why the doodle, that logo is kind of like old. So thanks to Google, like we are here, we are using, yes. Thanks for the response, Rajendra Prasad. Yeah, it's 27th birthday. So that's the thing. That's one of the things. So that's the specialty to it. So we are literally using one of Google's services, Google Meet. Okay. So moving on, that ransomware reality. So it's currently kind of like one of the #1 cyber threats that's being faced all around the world, including like us. We have also faced this. Any of you guys know which ransomware was the one that kind of like made its way to India? It was a global phenomena. There's a name for that ransomware. It's, shall I say? It's a WannaCry. It was like way back in 2017. I kind of like encrypted most of the unpatched machines or like outdated OS running machines. So the thing was that we were not like fully like digitized or digital in the digital ecosystem at that time. So like not much of an issue, but yeah, most of some areas we had a lot of problems. So the main thing regarding ransomware is that the threat is kind of like it's a huge and its impact is very, very huge. Okay. So in the early 2000s, the primitive version of ransomware were there, like lockwares. What they do is kind of like, if you're using a browser, that browser kind of like expands into full screen, it will take over your screen, and that malware controlling the browser also will control your keyboard. It will disable your shortcuts, so you cannot kind of like press like Alt F4 for closing the browser or disabling it, anything like that. So it fully controls the whole of the system and also change your user credentials. So this was the primitive version of the ransomware, the early 2000s. And moving on to 2010s, that's where this file encryption ransomware kind of like taking place. So that's where the WannaCry. WannaCry do have a huge history, like it's because of an issue with the Windows OS. It's known as Eternal Blue, the blue screen of death. You guys know, right? There's a blue screen of like error happens when you like an out of memory or something, any issues with the OS. So NSA, the National Security Agency, kind of like developed an exploit for this, and it was used for the previous older versions for the Windows, like the XP, Vista, things like that. And what they do is that what they thought was that like, okay, we have moved on, like this XP and those OS versions are like before 2010. So it's 2016 or something like that. So they decided to publish this exploit, and like it made it way to like the Korean hackers. So they were the people who launched this huge ransomware attack back in 2017, the WannaCry attack. Okay, so we were also a victim of that. So present day, this ransomware is used as a service. Can you believe it? Just like cloud, the infrastructure as a service, or like what to say, the software as a service, ransomware as a service. It's been used by so many kind of like state-sponsored attackers, hackers. So that's regarding the ransomware part and the ransomware evolution. Introducing the three teams. Even though I have mentioned the red and blue, there comes another team, purple. So what does the red team do? They mimic what these hackers do. So these like three teams are like part of the organization. So if you're in a company, you have dedicated security, and these security team kind of like have these dedicated teams. They have this imaginary logical teams group. So they will pose as an attacker. That attackers are considered to be the red team, and the people who are defending the security or taking secure measures for all the devices in the organizations are considered to the blue team. So they should sharpen their skill. They should be quick-eyed, quick thinking, like how to block this like malware or malicious attacks from beyond. Okay, and third, like purple team is considered to be the collaboration. So this collaboration is what's happening in the organization at the moment. So the thing is that the ransomware has a specific set of steps, or the team or the hackers that launch this attack use this specific set of steps. So the first one is the initial access. That means gaining access and like gripping a foothold onto the device through the network. That's through internet, of course. And after gaining access, you are logged in as a user. Like the attacker gains user access, and he will try to change his user privilege. Like it may be a lower privileged user. He will try to escalate it into a super admin, so he can do whatever he wants. And the third one is the defense evasion. So from that particular system, he tries to kind of like monitor all the other system. Is there any other way? So from that particular machine, he kind of like tries to move on to look into any other machines with like any other data, any backup machines are there in the network, so he can launch an attack, go to it and wipe up all the backup data. So these are all the things that's happened in the after the defense evasion step, and that through by avoiding the firewalls and other detection systems. Okay, and the last step is encrypting. So when encryption happens, we can't do nothing. Like the key is with the hacker. So once it's fully encrypted, even though like decipher keys are there with the FBI and like higher level organization, the chances of like fully decrypting data is kind of like slim. Anyway, so the end goal of the hacker is to like kind of like exfiltrate the data, encrypt everything, and to keep his like in his ownership. So when you reach the machine and like it's locked, there is no like way to access your data, your confidential data, and it can only be accessed with the help of this attacker, and the help or like and his assistance is like you should pay a huge ransom. So that's how this this term kind of popped up, ransomware. Okay, so you need to pay a huge ransom to get your data back safe and sound. So initial access. So we are kind of like going through the red team and the blue team defenses. So I believe like, are you people familiar with this site, Shodan? It's kind of like, anyway, it's not legal, by the way. So if I kind of like So this particular site, what it does is that it kind of like scrapes all the machines that's connected into the internet. So the unpatched. So what I put in the search for this showdown is that for a webcam. Okay. So it kind of like lists me all the webcams that are available, publicly available. Like if I kind of like clicked on it, yeah, we can kind of like see it live. Okay. Anyway, I am not doing that. Okay. So that's not a good thing. So the thing is that the point I'm trying to make is that anything which is in the internet ecosystem is vulnerable to attacks. So that's the thing. So this is one of the things. It's just a small example that I showed. So that's how like this attackers, they have like pre-written scripts. They run the script every minute trying to identify or scrape the whole internet, trying to identify any exposed servers. It can be an AWS instance or a GCP instance or an Azure instance, a VM. So it will get those like with the help of AI, it's getting much more complicated and sophisticated, the attacks. So they will like easily they'll get our data. Okay, so and so machine is up and like it's not patched, the version, the banner of that server, like the particular version. So if any vulnerability for that particular version is there, and like is any POC, proof of concept is there, how to hack. So that's how the like the normal attackers do. So that's what the red team does.
CB Matthew?
Yeah.
Small thing.
Yes.
Actually, attack will be on data center and servers or clients also.
Yes.
No, I want to know
Yes.
this ransomware attack. You told red, blue, or something like that.
Yeah.
So which
Yeah.
will be attacked in the data center, all the servers or within the network, intranet or internet or something.
Yes.
Can you clarify, please?
All are prone to attack.
Okay.
Yeah.
Okay.
It doesn't means that like it's kind of like target. Yeah, some like what to say, some big groups like APT, Advanced Persistent Threat, they kind of target big pharmas, hospitals, healthcares, or banking. Yeah.
Application servers, email
Yeah.
servers, something
Yes.
like that.
Yes.
Okay.
And the entry point is through like phishing. Actually, that's one of the entry. That's most entry. And sometimes like some employees, they're kind of like they don't know. They kind of like download and execute any unwanted EXEs, right? That kind of like kind of put a strong foothold on your system, and that kind of like paves a way for the ransomware to happen.
We suffered actually. We suffered. That's why I'm
Okay.
asking.
Oh yeah.
Welcome.
Yeah. Actually, the thing is that it's not prone. Actually, I had a video, but the thing is that it's like only for it's from my state. So like this is happening
Thank you,
all
thank
India. I had a
Thank you.
video for that. Okay. So
Thank
the
you.
funny thing is that this. Thanks for asking this question, by the way. So I would like to take an example. So back in 2017, here in Kerala, we have the state Wayanad. So there, a panchayat had some machines from like all the PCs only, Windows XP. It all got ransomware infected. That's one of the funny thing. And one guy kind of like said like, what the hell is there in that machines? Are these hackers kind of like, are they beggars or something? Is there any data? Anyway, data is precious. At that time, it's the all the PCs. And if we are not up to date, if we don't update our software, we are prone to attacks. I believe all of you are like aware of the fact that Windows 10 is kind of, the support is kind of ending at this coming October. So Microsoft is pushing everyone, literally everyone.
Yes, October
Yeah,
10th is the last
to-
date. I know that. Yes, sir.
Yes. So they are kind of like pushing us to adopt Windows 11. I personally hate Windows 11. I love Windows 10, but what to do? So that's the thing. So we as defenders, the defense team, the blue team of the organization, they always take the measures to do the patching. They kind of like put a mail to all the employees and also awareness regarding especially phishing. So even phishing is kind of like served as a service. PAS, PHAAS. So that's one of the things that Blue Team does. And the other thing is you guys always should enable MFA, multi-factor authentication, for all your mails. Okay. And if any, like, and all these servers also, like there are central servers, right? There are critical, which handles critical data, especially the backup servers. It also should have like MFAs enabled. And adequate security awareness training to all the employees. And also the vulnerability management that is done by our like operations team or the security team. They kind of like advise or they kind of like monitor the current threats that are running wild in the ecosystem, and based on it they will check the org related, like the projects as well as the org related servers, the machines, the OS, everything, and they will try to look and like check if anything is outdated. So based on that, anyway, based on like the simple thing is that if like we have an endpoint, of course, so in that endpoint the report will come for the attackers that are trying to attack and everything. So based on that, we will take adequate necessary mitigation steps. So that's what we do. So the red team tactics is basically, anyway, all are prone to, even Microsoft got breached back in 2024 due to a phishing mail. You guys can Google it up. So that's one of the things. So it's still, even though it's an old school method, it's still kind of like it's kind of like it works. It works like magic. So these are the things that red team does and what like blue team does as a response. So moving on to the next slide, the execution and privilege escalation. So once this particular like red teamer, since like I am speaking based on the organization only, so red teamer is literally the hacker. So what he does is that he tries to gain access onto the machine. Once he gained access, what he'll use any software or any particular kind of script or any built-in, he'll literally search for any other vulnerability within the machine, within the server, and for that library we can execute payloads. Payloads is simply like a set of commands or set of strings that kind of like get an like what to say, it will literally make the hacker do his job, like will give him or her a root level access. So that, let me show you one. So like this is one of what to say, this is for like the Linux and Unix binary related, like shell commands related payload scripts. So these are all the binaries. These are literally all the commands that's present in your Linux machine or Unix machine. So these are all the functions related to that. So if I click on any, okay, apt-get, so it will take me to that page. Okay, so I have a particular command. Okay, if I run this command, I can kind of like break. So that what it says here can be used to break out from restricted environments by spawning a new shell. So once I run this command on any vulnerable, so that's the point. If your system is not patched, as a red teamer, as an attacker, I can literally go into this site and kind of like choose any library. Okay, any vulnerable library for that OS version, and I can kind of like just literally like run these steps and I can easily gain root access. So that's what the red teamers do, or the hackers do. Okay, that's the same thing that's been explained here in this slide. So a red teamer gains control by using this solely. So this is how he like literally runs a set of commands that kind of escalates his privilege to a root user. And once you are the root user or a super admin, you can do whatever you want with that machine. Okay, so as a blue teamer, as a defender, what we should do is that we should have EDR. That's the thing that I mentioned here. We have endpoint detection and response that kind of like literally tracks, monitor all these things, and that should kind of enforce that least privilege policy. Okay, I believe like if all the users in a company is given Mohammed, yes, SOC, yeah. So most of the users, if like all the users are given like full admin privilege, that's a huge risk for an organization. So they should be given least privilege. That's a methodology that we should always kind of like do in practice. We should adopt, okay, the least privilege. So that's the thing that we should always keep. So there should be an EDR. So EDR, like most of this, we have Sophos here. So it kind of like updates its DB. So it has kind of all the malware related, the hashes. So any new malware pops into the environment, into the ecosystem, into the wild, this EDR will automatically get like the central server get updated with this malware hash, and particularly this will be pushed on to all the devices, and all the endpoint devices, all the laptops, all the people's laptops will have this hash, and they will check if any of the malware is present or not. Okay, if anything like that is downloaded, it will be immediately discarded. Anyway, like our browsers are so like highly advanced at the moment. If you guys kind of like try to download a like from not secure site or like any exes, your browsers kind of discards it, right? Have you guys tried doing something like that recently? Anybody? So browsers are also kind of like acting as protection. Also, Windows as is built in like Windows security. Anyway, EDR is a must. Okay, so that's the one of the thing. And as the I believe his name was Mohammed mentioned, SOC. That's one of the thing that an organization has a must should have. Okay. Then after this attacker, the red teamer becomes a root. What he does is he kind of like creates a backdoor, like a backdoor to like a stage drama. Like all the stages have backdoors, right? For exclusive people, like that program performing people related, supporting people, for them to have access, there's a backdoor. Similarly, for this attacker to have access, he will create multiple backdoors. So if one door is closed, another door is open. So that's the thing. So he will kind of like literally create all the backdoors, check all vulnerabilities, and try kind of like the maximum he can do, he'll do it. That's regarding so that's how he will maintain the persistence. We think that we have literally blocked him, but no, it's only his one door that's closed, but there are literally several doors open. So that's one of the things regarding the red team persistence. And when it comes to blue team, like mentioned earlier, SOC, there should be continuous monitoring regarding what all kind of like activities are happening in the network, and the security control should be superb, and it should be highly tight. Like if any unwanted or any kind of like intermittent kind of like network activities happen, like we should be alerted immediately regarding like something's wrong. So that should be in place. SOC or SIEM, system like security information management, SIEM, like all the like methodologies that takes care of these things. Okay. So that's regarding the persistent and defense evasion. So moving on, the encryption and exfiltration. So after this attacker gained access, he kind of like escalated his privilege from a normal user to a root user or a super admin. And after that, he kind of like created backdoors so that in future he can access from any other way, not the same way. And after that step comes this encryption and exfiltration. So this is that critical moment regarding the what to say, as clients or as an org. It's kind of like a huge blow for us. So this is where that encryption part takes place.
Sir, one minute. Sir,
Yes,
this
Nausha, please.
exfiltration, what example, sir? Exfiltration, for example, real time example.
Example meaning like like if any hacker kind of like if any healthcare or hospital got attacked by a malware, their data is kind of like encrypted and stolen. That stealing is kind of like known as the exfiltration, data exfiltration.
Okay, thanks.
It's just exfiltrate, like stealing. That's the another word only, nothing else. So they kind of like
Thank you.
steal this data and they will sell it in the dark web. You know which data is the highest bid data in the dark web or the dark forums? Is this hospital data only, because it includes all the information, or your health, your credit card, your address, everything is there. That's the thing. Okay. So after becoming root and after like creating the backdoors, the first step, this ransomware, people who lost does is that they kind of encrypt this critical files, these critical business files and databases. They are encrypted with strong algorithms. That's one of the steps. Okay. So what we can do is that like if a good organization always have multi-tier backup. Okay, one on-premise, one like 50 to 100 kilometers away in another center, and one in the cloud. Okay, if that kind of like methodology is there, okay, they are safe. But the other fact is that this data is stolen. That's the other risk that we are facing. So the attacker, like they will kind of like try to say, okay, so you should pay this much ransom. Okay, then we will not publish your data in the dark web. So that's the catch here. And the funny thing is that even after the file encryption, these attackers kind of like try to detect these backup servers on premise in the network. So they will literally kind of scan the entire area and kind of like locate, because all these servers have banners. I believe you people know like logo banners and all, because all the servers, if you visit, like if you get any error, any FIO2 error, something like that, like if you have accidentally, I believe you might have actually bumped onto any servers like Apache, there will be a page with the name of the service. If it's Apache, Nginx with the version number. So that's a huge red flag. So that might give away the attacker like what the version is and make him identify the vulnerability of that version of that service, and he may launch an attack onto that server. So after gaining foothold onto the in a machine, the ransomware, the attacker kind of like tries to locate the backup. So that's the backup targeting, the other step. So attackers specifically target these backup systems. So like the organization have like the only kind of like way to restore this lost data is from their backup. If the backup is destroyed, then what can we do? Anyway, nothing, no way. So all hope is lost. So that's what after the file encryption, the attackers do. And so how to kind of like avoid all these is that we need to isolate these backup server from the normal network. So this happened here because the backup server is in the same kind of like in the network as that of an employee or as that of a normal kind of like person, a guest who is coming and like if any guest is visiting to an organization, he is kind of like temporarily granted internet access if on request only. So there are adequate policies and stuff like that. Like his machine will be scanned if any issues like any like kind of like virus or trojans or malwares are present or not. And after that only like he'll be connected. Even though after getting connected, he might if he do any dubious things, then like we can't do anything. So in order to avoid this complication, what we need to do is that there should be a proper network segmentation within the organization or within any, whether it be hospital, whether it be bank, or whether it be a company, there should be a network segmentation, proper network segmentation, so that this wouldn't get through. Okay, so that's the job of the blue team, the SecOps, the info security, security operations. So they should create a particular isolated network for the servers, let alone the backup server and the normal employees. So this wouldn't get through to that network. So that's where the network segmentation part comes. And after that, as Naushad had asked, the data exfiltration, like when the proper backup is there, no need to worry. But the thing is that that particular the machine is affected and the data has been stolen. So, okay, if like there should be a backup, okay, it can be restored. But the fact is that the data got stolen. That's a huge risk. So we need to kind of like take adequate response. We need to inform the stakeholders and also calculate the losses. So that's all the things that we can do. So these are the things. So the main thing is that proper backup and network segmentation. If these two are properly running in an organization, whether it be hospital, whether it be bank, whether it be any other company's organization, then we don't need to be afraid. Okay. So that's the thing. So after all these steps, the final stage, there will be a message displayed on the screen stating that your data has been or your files have been encrypted. You should pay so and so in Bitcoins, because Bitcoin can be like the transaction cannot be traced. That's why they are always doing the payments in Bitcoin within 72 hours. It doesn't mean that it should be done in 72 hours. The hours also vary. Okay. So this is the final stage of what this attackers kind of like do, and the final stage of the ransomware. So let me share my screen. So I have mentioned about WannaCry, right? So this is the thing that launched the ransomware trend. So this is that first ransomware. This Eternal Blue exploit is the thing that what I have mentioned earlier. It's an exploit developed by the NSA, okay, National Security Agency of the US only. So the thing that we should always understand is that for every tools, I believe it's my personal view only, for every tool service, every OS, every services that we use, all of it have backdoors, especially all of it can be reverse engineered. But we see it's not the reality. So in this case, Eternal Blue, it's an already existing memory kind of like buffer overflow kind of issue in the older machines in Windows XP and all. And it had an exploit developed by the NSA, and they kind of, I have like I have mentioned earlier. After the 2010, when it's around 2015 or 16, something like that, they published it. Okay, they released this tool. Okay, because they thought most of the people have switched on to Windows 7 or any OS higher, Windows 7 or Windows 8, and they thought, okay, it's safe for us to release it. That's where things all went wrong, because we always tend to use the older machines because we have some kind of nostalgia attached to it. Okay, so that's how this got launched. This was launched by, it's given as likely North Korea. I believe you guys can see it, right? Here in the screen. So they only launched it with the help of NSA. If NSA didn't do it, then like this is not possible at all. So because of that, okay. So it's a famous ransomware. It uses this exploit, and it kind of like infected like this many computers worldwide. That's a huge threat, and it's still kind of like the variants of this ransomware is still there. And mind you guys, never ever call all these IPs or these domains, okay? Because it might introduce a ransomware onto your machine. That's right. Okay. Mohammed, please.
Just now, sir, you told never says IP address. I didn't get this.
Not never say, never call it. Kind of like copy and call it on URL. If ransomware, if it's still active, then it will infect your machine. That's right. It will communicate and infect your machine. Okay.
Actually, Eternal Blue, it's comes with Windows XP only. When we
yes,
are going to hack the systems,
yes.
is it
No,
having
no.
some particular port like SMB, some other kind of ports? Eternal Blue.
SMB calls?
Because I tried once to hack the system, my system only in VMware.
Okay.
So at that time, it comes with Eternal Blue Windows something.
Yes.
With that vulnerability, I can able to hack the system.
Okay. Your question is, Mohammed?
Yes, sir.
I didn't get your question. Yeah, with that vulnerability, we can hack the machine. Yes. What I pointed here is that like never call these IPs, because I believe most of them might be brought down. But anyway, it's not safe to call this.
Because private IP address will be different. For example, my system private IP address will be different. Your private IP address different. If you are connecting with the same network, public IP, then we can able to hack the system.
The thing is that okay, that's good. That's a point. But what I'm trying to, these are all public IPs, right? So these host the malwares.
Yeah.
If you call that you will invite the malware onto your machine. That's what I said. Okay. Anyway, so this is I will show you like what happens. So this is a small bit regarding how this ransomware process happens. Okay. So once it gets executed in the background, it kind of like converts all your kind of like renames all the files existence, the extension, not the existence, file extension. They won't even let you open a single small PNG file.
Sir, please send this video link, sir. It is a fine video. We can say show it to students.
You want me to share this video?
Yes, sir. Because we can show it to students.
Yes, yes, yes.
The video
Actually,
link.
it's from. Yeah, I'll just post this link on the chat. It's simple. Like you guys should know, like there's a website called Any Run, kind of like it has all these kind of malwares and all the demos are there and everything. So this is how the end result of a ransomware looks like. Okay, I have put the link of this. All right. I have put it in the chat. So that's one of the demonstrations. So it's hosted by Any Run. It's kind of a site which is kind of dedicated to all these running of malwares and all. Okay. It can be run in a controlled environment. I hope my screen is visible.
No, sir. That small video, sir. Video.
Video is enough?
Ransomware video.
Okay, then
No,
like,
video, sir.
okay,
No,
I'll
it is
share it.
okay.
Yeah.
Video is there.
Yes.
Video link.
Yeah, then, okay. I have pasted the link in the chat. You can open it and the video is there. You can download it from there. Okay.
Okay. Okay. Thank you.
Is my slide visible? Okay. Yes. Okay. Perfect. So that's how this impacts. That's how the kind of like encryption process takes place and all. At the end, you can see like Bitcoin notice is there. You should pay so and so amount in Bitcoins, and there's a hash is there. Okay. So any of you guys know how this WannaCry ransomware was stopped? Any idea?
Sorry, please again repeat.
This WannaCry ransomware was one of the most huge ransomware attack back in 2017. So how it got stopped? Any idea? It was spreading very fast. That's one of the things. So it got stopped at the point. That's why like a global outage wasn't there. It was kind of like causing almost a global outage at that moment. Any idea? Actually, yes. Now, sure. It was like a small mistake from the attacker, actually. Can you guys can Google it if you want?
Actually, here it says one of the researcher activated its kill switch domain, which prevented future spread of the ransomware. Something it is mentioned.
Yes, thanks.
I didn't get it.
Thanks, Mohammed. Thanks. Yeah. The thing is that you know domains, right? Simple website, web domains.
Yeah.
.com, Facebook.com, Google.com.
Yes.
Your company,
Yes.
yeah. So the thing is that domains are not free, right? Are
Yes.
domains free? No, domains are not free, right? So we should pay that particular domain hosting provider, that domain provider, an amount to host our domain, right? So that's where the attacker got defeated, because this particular ransomware was spreading to a particular kind of a domain. And this researcher, what this person did is that he kind of like, while he was analyzing the malware, this ransomware, he was kind of like trying to figure out like what all things are happening in the background. And while he was checking line by line, and at a particular point, he found out that this was communicating to a particular domain. So he was curious. He went and checked if this domain is active and who is the owner of this domain. And when he checked, nobody is the owner. It's simply kind of like it's there. So what he did is that he registered that domain. So once he registered it, it became his domain, and the attackers got lost. Like their access to this domain got lost. So that's how this huge growing threat was kind of like defeated. So that's one of the huge things, huge twist actually. It wasn't any kind of our defense mechanism, but it kind of paved the way for us to be much more cautious regarding these kind of scenarios. So that's the thing, that's the lesson that we learned. Okay, so now we are moving on to 2021. Okay, in May 2021, Colonial Pipeline. It's a huge kind of like a refined petroleum products pipeline. Its length is kind of like it's stretching from 5,000 miles. It's literally kind of like 8,000 kilometers. Like if I'm from Kerala, by the way. So from here in from our capital city, Trivandrum, to Kolkata. That's the distance of this pipeline. It's a petroleum pipeline, you should know, the US. And this got attacked. Ransomware attack. Okay. So how this happened? It was a huge issue, and kind of the president was Biden. He declared it as a state of emergency at that time, and its impact was a colossal impact, kind of like affected the most about 14 states of the District of Columbia. The US energy infrastructure was severely affected. The thing is that how this got happened. So those are the steps that are being given here as a case study. The initial breach happened because of a compromised VPN account. And the funny thing is that how this got compromised, that account didn't have an MFA. Simple thing, right? That particular VPN account didn't have an MFA enabled. So you can literally kind of like throw in a random user, random password, brute force it. Yep. So that got compromised. The attacker got the access. So that's how it got breached. And the encryption was kind of like caused. The next step is the system encryption that we have seen earlier. It kind of like encrypted all the control system that were controlling the pipeline. So all the pipeline, the petroleum pipeline activities and everything, which forced the infrastructure, the team, the Colonial Pipeline team, to shut down the operation of it. Okay. And this made a huge national impact. That's the third point. fuel delivery across the eastern US. All the eastern US fuel delivery were disrupted, and that was like for several days. So the impact is huge. Okay. Anyway, we know that an attacker, launching a ransomware attack, they want some money, right? A small amount of, it's not small for us, by the way. The company paid an amount of 4.4 million as a ransom. So they can kind of like decrypt and gain access. Okay. So here, it's not the data actually. Here, it's the operations. Okay. The systems were all locked. So they weren't able to operate. Okay. That's one of the things. And anyway, like after like with the help of FBI, they were able to decrypt some of the systems and also restore the machines, and also they were able to recover the funds. Okay, they've been tracing all these transactions. They have the tools, okay, that we don't know. So they were able to do it, and they were able to recover some of the funds. So the moral of the story is that one little weak credential caused this huge issue, huge national issue. It's just a one. It might be an employee's credential or something. We don't know. It's even though it's a small thing, the impact is very, very huge. It's large. So that's one of the takeaway regarding this case study of the Colonial Pipeline attack. You guys can like look through, go through it, go through it. Okay. So from all these things, the different strengths of this red team, the attackers, and the blue team, the defenders, are is that they're kind of like the attacks always evolve, right? They don't always attack the same way. So that's the red team advantage for the creativity and innovation, and also the speed and execution. Now it's kind of like an AI era. So AI agents are kind of like launched to kind of this launch more and more attacks, even botnet attacks. Like, I believe you guys are familiar with botnet attacks, right? Like any compromised Wi-Fi or any smart devices, any IoT devices compromised, vulnerable, an attacker can kind of like gain access to it and make it as one of his minions, and kind of make it launch an attack. Thanks, Mahola. So a botnet, like it appears like as if like even though like I am accessing these like internet service or something like that, my Wi-Fi is also at the same time a vulnerable Wi-Fi attacking some other government agency's site. Okay, a DDoS attack maybe. So botnets are like that, kind of like compromised. So the red team kind of that attacker perspective, that creativity, speed of execution is kind of like always kind of, they always kind of learn from their mistakes and try to do more and more new methodological attacks. Regarding this, there are like a lot of frameworks actually, like MITRE frameworks, things like that are there. That's a huge, entirely different topic. So I'm not like digging into it. And like when it comes to the blue team, what we can do is that we need to be always, we should keep our eyes open, 24/7 monitoring, and we should always like the threat intelligence regarding emerging threats in the wild, in the internet ecosystem. We need to be aware of it. I think were you guys did you guys came across the news regarding the NPM package related issue? Anybody? NPM package, Node. Nobody's familiar with that? Naushad, Mohammed, are you guys familiar with that?
No, sir.
No, okay. Anyway, okay. It's used for development actually. So the thing is that like 2 weeks back, this is an open source library. Okay, that's one of the major like most thing. Like I am a huge open source lover as well. Even though we boast and we say okay, like open source is so and so good, giving things for free. The thing is that this npm, the source report repository, uh, like they had a developer. That developer kind of like committed malicious codes onto most of the libraries. Okay. And the thing is that everywhere in the world, most of the people use this, right? And these libraries have backdoors. And the funny thing is that that attacker can use it and access anyone's like project or like machine or something like that, because this particular library is there. So it's a huge risk. Even like it came to us and we kind of like took the appropriate remediation. Like the will be always figured out by the npm team only. The team that's providing the package, they will kind of like resolve the issue by updating a patch. That's why we should always update our softwares, whether it be like the browser or your OS or your phone, like applications, WhatsApp, Instagram, and everything like that. It should always be updated so that it will be secure. So that's the main thing regarding the blue team. Okay. So how this defense in depth we can do. These are all the things. The data should be securely encrypted from our end. Okay. And the applications also needs to be secure. And this can be done with the help of EDRs. Okay. And also data encryption proprietary tools, and also built-in data encryptions. Like Windows does have data encryption also. Okay, so we always enforce it in our organization as well. And the endpoint network level, that defense is managed by the firewalls. So we have what to say, different firewalls and all. Some might cause some issues, some EDRs might cause issue. I think all of you guys are familiar with the CrowdStrike thing that happened last year. That one update kind of made a mess, huge mess all around the world. You guys know CrowdStrike?
It is a soft tool.
Yeah. It's similar. It's similar to like it's similar to this or EDR or antivirus kind of. So they kind of like pushed a like what to say, an unwanted update. It messed up everything, every services, airports, airlines, railways, everything messed up all around the world. All organization affected, and the business loss was huge for everywhere. So that also, so that is kind of that was sort of like a supply chain attack. Because of CrowdStrike, some companies were not able to do their work, and the sysadmins were forced to like go to like line by line, or the employees were forced to come into the office, and the laptops were manually kind of like reset. So that was the thing that happened. So these kind of like the thing is that the moral of the story is that the network endpoints are all things are managed with the help of the EDR and also the firewalls. And even like at the end of the day, it's us humans that we should be careful. Okay, we should be aware, because we are the people who are interacting with all these things, and we should be aware of what all things that we are doing. So that's why at the 5th step, we are given identity and access. So as like a privileged person or like from the operations or IT operations, security operations team, what we always advise is that a particular, like, if a person doesn't require any unwanted access to a resource, he should not be given that. Like, for example, if a laptop is configured for a new employee, we wouldn't give him any full privilege. We'll only give him the required privileges only. Okay, that's the identity and access. So based on the requirement, that privilege is given. Okay. So combine these things, the red team and blue team. We will be doing the purple teaming collaboration. So if the red and blue teams work together, like instead of like in two silos, meaning two isolations, instead of that, if we share our knowledge, we can kind of like overcome our weakness. We can sharpen our skills. We can withstand all these attacks, overcome it step by step. And our security posture, our defense become much more stronger day by day. So with this collaborative approach and this, faster learning of the threats that are happening and how to mitigate, and with this security defense, that kind of improvement and that focus, we can overcome this ransomware or any malicious threat. So since like we have all listened to all these things, I'm gonna ask you a question regarding a hospital. Actually, a hospital kind of phishing attack. An attacker launched a hospital phishing attack. The scenario is that a hospital receives a phishing email with a malicious Excel attachment. Okay, it's claiming that it's from a like patient. It's a patient transfer request, something like that. It's a file. So my first question, as a red teamer, what is your next move? That file is opened, so you have got some kind of access. So what will you do as a red teamer? I'm curious to listen to your answers. Anyone can answer. Nobody?
Disconnect that system from other network.
Actually, that's that answer should have been both the blue team. Okay, blue team answer you have said. That's a good. Thank you.
Thank you.
That's one of the like major things as a blue teamer. Once like a machine, a device is affected, you should right away isolate it from the network and check it out. What exactly kind of like
As a red team, I think we need to find the vulnerability, find the bugs.
Yes. Come on, Mohammed. Yeah.
Before that, we need to take some authorization from the organization.
Yes. Yeah, we should like this is actually yeah. When we formally do something like pen testing or like things like this, we always get the approval from the relevant organization. That's a must. So from an attacker perspective, as a red teamer, like what we should do is that what Mohammed said is right. Like you will check for the vulnerabilities in the machine. Like it can be further escalated. Further any privilege escalation can be made, and from that we can kind of create a backdoor, create a steady kind of like a session with the device and check for any other machines in the network, and so it goes forth, and hence we can like kind of like back up the whole hospital, I think. Yes. And what a doctor, I believe, Savita, your name is fully not. Yes. Thanks, doctor, for your response. That's the right answer, actually. Once this happens, that particular machine needs to be isolated. That's the first thing that we should do. Okay. So that's regarding the scenario. Thank you. Thank you. Thanks, Mohammed. Thanks, Dr. Sauda. So back to the best practices in the age of ransomware. So these are the things that we should. Yes, Naushad, please. Yes, Naushad, do you have to? You have anything to say?
No, sorry. Sir.
Okay, no problem. Yes, Ganapati, please.
Sir, actually, regarding this ransomware,
Yes.
nowadays, 0-day attack also nowadays more because we cannot fix the.
Yeah, zero-day exploit. Yes, zero-day exploit.
So what we have to do for that, sir? Please. Some of the servers are attacked even before fixing any. We have to isolate some of the missions. Some of the databases we may get SQL Server or Oracle, something, injection.
For the zero-day attack, if any patch is available at the moment, then we are safe.
Okay.
If there is no patch, then we can do anything.
Achha.
That's how it works. That's why it's called zero-day actually.
Okay, sir.
Because
that is happening actually. Government systems.
yeah.
Recently that.
Yeah, it happens. Yeah,
Yes,
it's actually action. Actually, Google Chrome already has a zero-day patch. I urge all of you guys to.
Yes, sir, please. Thank you.
Yes. The thing is that if there is no patch, then we need to kind of like harden our, like I have mentioned earlier, the access to the system, the services and all should be limited, and that particular server should be hardened. Like the ban of the details of that server shouldn't be revealed, because these attackers kind of like scrape the internet. If they are able to discover the version,
Okay.
that's how they target your machine. If they are not able to, we can kind of configure. We can do custom configuration. We can harden the servers. Server hardening is a must. So that's one of the things that we can do to prevent from happening. The other is the firewall and everything.
The hardware and software firewall to be strengthened more. Okay.
Yes. And this network segmentation. Yes, Ganapati, please. Okay. Anyway, thanks for bringing that up. Zero-day exploit is a huge headache. So coming back to our session, the best practices in this age, since this is based on ransomware, this can be used for all the other malwares and other exploits and like other threats or vulnerabilities that we face. These are all the best practices that we should always keep a zero trust architecture. That's the main thing. Like never always trust like any person. It's not like the human trust, it's regarding the access related. Because once that person's credentials might be weak. Anyway, at the moment, like all the services are enforcing like strict and strong credentials. So based on that, you should create a strong credential. So it's not an issue. Anyway, an MFA should be considered as a must. No. Zero trust architecture meaning like we should provide only the required privileges or permission for that particular service or a particular person accessing a resource, a limited like a read only permission, something kind of that based on the role. Okay, that should be given. And the next one is we should always have a backup. Without backup, then they will all back up. That's the thing. So we should always have a strong backup strategy so that if any attack happens, we should continue our business. That business continuity should be maintained, right? So with that only, we can kind of like, without any business loss, we can continue our business operations. So a strong backup strategy needs to be in place. The other thing is regular red blue exercises within whether it be any organization, it should be done. It should be a must. Then only we can identify our loopholes, whether it be any compliance related or whether it be any other what to say, vulnerabilities, any trend kind of like trending threats and all. Based on that, we should, and we as a must, we should do all the regular red or blue exercises. And at the end of the day, user awareness. Okay. Because us humans are the first line of defense through education and training. And also, do you know what is the, how to say, weakest link in cybersecurity? Anyone? Anybody knows? Weakest link in the cybersecurity chain.
Sir, giving
Human error. Human error.
Giving
Dr.
permission to
Savita.
Human error, sir, it is.
Yes. Right answer again. I think you are more into the defense side. Yes. I'm a huge offense like red team lover. So that's one of the main things actually. Us humans are the weakest link when it comes to cybersecurity. So the thing is that, as I have mentioned earlier, that Microsoft incident or this Colonial Pipeline incident, phishing triggered these events. When for Colonial, actually, it's the MFA of the VPN, because a proper the credential wasn't maintained, and this extra layer of security, this MFA was not enabled. When it comes to the Microsoft incident, it was phishing. It happened last year. So and so, phishing is still there. The things like this happen. People like if they receive some kind of like a mail like you have $1 million, just click on this link to reclaim, and like I don't know, there are people that still goes after it. So that proper awareness needs to be provided. And also when like sure, Elagon, I will do it. So also the thing that needs to be done is that yes, Elagon, I'll share. As like proper there's a noise actually. Okay. So users should
Sir,
be.
I have one doubt.
Yes, please.
One of my student, he want to purchase
Yes.
new mobile.
Nice.
So like I think like we have like nowadays Flipkart and Amazon. So
Yes.
he's going means he used his father's mobile to purchase it. So I think that website is I think fake website. So they said that tell me the OTP which is received to your mobile, means his father mobile. So he told
Okay.
the
Okay.
OTP. He told the OTP within few means less time. Nearly 1 lakh deducted from his father's account. And they told that one more thing, if you tell this OTP or something, one more attack on him. If you tell this, that item will be within 1 or 2 days, it will receive to you. Means fast, what we can say, delivery.
I think it's fake. It needs to be reported. Was this reported to the police?
Yes, means that that is one of phishing attack only, no?
Yes, yes. Actually, not just phishing, it's social engineering. Social engineering, like it appears as if it's authentic and it's real, but it's not real. It's just a fake like page. It appears as if it's from an official application or like page and all. Even like those things are trending right away at the moment, like Malwarebytes application are like the tools that are used for scanning these malwares and all. Those are also like provided in GitHub with malicious codes in that official exe files. So when you run it on your machines, like the attacker gains access to your machine as well. So here in this case, it's social engineering actually. So they have kind of like made your student believe like it's authentic, even though it's not. So what we can do is that let the law enforcement handle it. We need to like report it right away. The main thing is that we should be aware, like as I was mentioning regarding the user awareness part. I got a bit distracted there because some noises were coming. So please do and kind of like report it and go to the nearest like especially the any cyber task force if it's there, and it's great because if like more and more cases are like there, then strong like search happens and the culprit can be get like he'll get caught eventually. So I hope that
Yeah,
happens.
But in my case, means it is my worst experience.
Okay.
Before COVID, I was traveling in the public bus in Hyderabad.
Okay.
So my new phone, that means someone took my new phone. So then I went to the nearest police station and I complained. So number of times I went there, but he said, see, once he used the phone only, we can track it. Even I gave the EMI numbers also. Even one day, sorry to say, I asked him to come out of the station, and I said I will give 5,000 rupees because it is new mobile, like 17,000. I will give 5,000 rupees. Please track it. So anyhow, I lost the trust on the cyber crime. I don't know. So like what we heard, antivirus will be developed by the company. Means virus will be developed by the companies. Means antivirus companies only. Like someone says, they both mingled, the polices and the robbers or thieves. We don't know, God know better, but no use. I think nearly 3-4 months I went to the cybercrime office, but no use.
Okay, that's an entirely different topic. Anyway, let's hope justice happens. Okay, so as users, we should be aware. We should like never kind of like go after things like this. We shouldn't get tricked. That's one of the things. Okay. So
Sir,
the
is
main
what I heard is correct, sir. The virus antivirus will be developed by virus will be developed by the antivirus companies.
things like that are like, the thing is that at the end of the day, everything is a myth. Privacy is a myth. I have like in the beginning, I have shown you guys that Shodan website, right? It's kind of like what kind of it scrapes all the devices that's kind of connected into the internet, and like from that also we can discover all the vulnerabilities and kind gain access. So everything is there. All our records and the data, even like once we enter a username and password, you know Google Password Manager in the browser right now, the Google Chrome. So once we enter a random password, I entered a random password. Actually, I was testing like a VM. No, actually not a VM. Actually, it's a form for like a program related, a login form. So while I was testing, I simply put up a random password. Right away, this Google Password Manager, like this is a breach. That's the notification which I got. This is a breach password. You shouldn't use this. Okay. So
Dear
that's one of
participants,
the things.
yeah.
Yes, Bismi.
Okay, sir, you can continue, sir.
Yes,
Or if
I
it's a
believe
session
there is
form
only
of-
like
right.
yeah.
Right.
So
Okay, sir.
yeah. It's only 4 minutes left.
Yeah,
So
yeah.
the
Okay, sir.
this is the ending slide actually. So the
Fine.
literal lesson is that like this battle, this red versus blue, all this like the state sponsored hackers or the attackers versus us, versus the organizations or the like the normal people or anything, let it be. It's not over. It goes on. So it's an eternal battle. So what we learn from this is that how to prevent all this, how this happens, and how to prevent all these things. So we should always understand this, that this never be over. It will go on. It will become much and more like it will become more sophisticated on the way. So we should be prepared at all times. And we should always wear that cyber defense armor, that blue team armor, and we should be ready. And we should also learn their trending methodologies and trending malwares and everything like that. Okay. So
Thank you, sir.
yeah.
Dear participants, if you have any queries, you can use this platform. If no more queries from the participant side, shall we move on to wind up this session? Good evening, one and all.
1 minute, madam. 1 minute. Sorry to interrupt. Sir,
No,
this
sir, no issues, sir.
dark web, globally, is it, sir, like legitimate one or dark web, sir?
Which one now, sir? Okay. Oh, no. That's entirely a different one. It's
What it
globally it's
means?
there.
Uh,
It's like
Is it
the thing is that
legitimate?
uh,
Legitimate?
yes, it's entirely different, and it's an entirely different topic. It's an ocean actually. Okay. It's the simple thing is that you cannot
That too
access
have
this
like-
normally. You shouldn't access it actually. It's not safe, and like the thing is that we use like Google, we use browser, and we have indexed like search engines and all. this place doesn't have those things. It's tricky. It's trickier, and there are a lot of traps. Okay.
So
Each and
Hi, sir.
each and every
But-
link, yeah, each and every link, like you go through, have some form of malware, any JavaScript kind of like that messes up your device, and you will be surveillance will be you will be surveilled by all these people from the dark web. They'll be like,
Oh,
why this guy entered, and they'll be like fully chasing after you.
but cyber investigators, they should know, no? They should know. They have to.
Yeah, they have access. They do have like certain protocols and all. That's a different story. Yes, they do have access. Yep.
Thank you, sir. Thank you, madam.
Hi, sir. This is Dr. Mohammad Ilham, sir. Actually, I'm
Dr.
working in Aurora University. I'm certified ethical hacker also.
Okay.
Your session was very good, sir. Unfortunately, I'm in the college right now,
Oh,
so I
okay.
am able to watch your whole video consistency because some network fluctuations also.
Okay.
So, sir, could you share your LinkedIn profile?
Yes, sure. I think Bismin can handle it. Yes.
Yeah. Sure. We'll share the profile with your permission, Sibisal.
Yes. Please do.
So we are moving to the official wind-up of the session. Good evening, all. It is with pleasure that I extend our heartfelt gratitude to Mr. C.B. Matthew George for his enlightening session on A Tale of Two Teams, Red versus Blue in the Age of Ransomware. Mr. C.B. began the session by mentioning Google's 27th birthday, a small detail that caught our attention and set the perfect stage for an engaging discussion. He then guided us through the roles of red, blue, and purple teams, explaining how these teams operate in cybersecurity. A particularly insightful part of the session was his explanation of the ransomware kill chain. He walked us through all the stages of it. He also shared real-world examples, including the WannaCry ransomware attack, which is a famous one, helping us understand how such threats work and how we can defend against them up to a certain level. Also, he clearly gives us idea about colonial pipeline attack, bottleneck attack, etc. We are really grateful for the practical examples, clear explanations, and interactive approach that made the session both informative and engaging. Your experience has certainly enhanced our understanding of offensive and defensive strategies in the age of ransomware. On behalf of the entire organizing team of this faculty development program, I sincerely thank Mr. C.P. Matthew George for sharing his knowledge and time with us today. We hope to continue learning from your insights in the future. Thank you once again. Thank you so much, sir.
Thank you. Thanks for inviting me. Thank you, Bismin. Thank you all. Take care.
Dear participants, that's come to the end of session 12. Since we are running out of scheduled time, let us move on to next session straightly, with your permission. Welcome, Dr. Khalid Professor. Moving ahead to last session of the 6-day online adult faculty development program on securing the future, cybersecurity, forensics, and the world of blockchain, hosted by the Department of Computer Applications, MES College, Marambal. It is my great pleasure to introduce today's distinguished speaker, Dr. Khalid Rafi, a leading expert in advanced and additive manufacturing technologies. Dr. Rafi currently serves as the Director of Training and Certification at the Global Advanced Manufacturing Division of ASTM International, Singapore. In this role, he spearheads worldwide training and certification programs in advanced manufacturing with a particular focus on additive manufacturing, more commonly known as 3D printing. With over 25 years of extensive experience spanning research, development, training, project execution, standards development, and Regulatory Affairs. Dr. Rafi sir has made remarkable contributions to both industry and academia. He has played a pivotal role in advanced additive manufacturing education and workforce development initiatives at ASTM and has led global programs through strong collaborations with industries, research institutes, and universities around the world. He earned his PhD in metallurgical and materials engineering from IIT Madras and has held positions at prestigious institutions such as Nanyang Technological University, Singapore, University of Louisville, USA, and UL International, Singapore. His pioneering work has significantly contributed to the qualification, validation, and standardization of additive manufacturing process, materials, and facilities. An accomplished researcher, he has authored over 40 publications in international journals and conferences, with his work cited more than 3,000 times worldwide. Beyond research, Dr. Rafi sir is a passionate educator and mentor, sharing his knowledge through invited lectures, workshops, and training sessions across Asia, Middle East, Europe, and United States. His contributions have been widely recognized, including honors from Singapore's Ministry of Defense for his work on military additive manufacturing standards, along with several prestigious fellowships and awards throughout his career. Without doubt, he is a pioneering scientist, visionary engineer, and global thought leader, shaping the future of manufacturing technologies. Today, he will be sharing his insights on physical cybersecurity in advanced manufacturing. Sir, we are really fortunate to have such an eminent and inspiring personality with us on today. And dear participants, please join me in giving a very warm welcome to Dr. Khalid Rafi, sir. Over to you, sir. Sorry, sir. You're
Okay. Good evening. Thank you so much for the introduction, and thank you all for participating for this last event, I believe. So that this is the 13th part of your FTP program, and I'm glad that I can talk something about advanced manufacturing and how cybersecurity is influencing the advanced manufacturing, and what kind of things that we need to take care of, the security aspects when it comes to advanced manufacturing. So let me share my screen quickly. Can you see my screen?
Yeah, it's visible, sir.
Presentation mode. Give me a moment, I will reconnect it because I need to go to the presentation mode right now.
Okay, sir.
Okay. I think you guys can see my screen right now. All right.
Yes.
Okay. So Today's presentation is on cyber physical security in advanced manufacturing. This presentation will be slightly different from what you guys heard in the past editions, because this is primarily focused on how cyber physical security systems are impacting advanced manufacturing. So my name is Khalid Rafi. In fact, you have given a great introduction. So I'm not going into the details of what I'm doing and where I'm from, but I just want to give you an idea about the organization I'm coming from. So I work for ASTM International. I'm not sure how many of you know about ASTM International, because this is primarily a standard development organization focusing on multiple industries, mechanical, civil, aerospace, all different sectors, not specifically on computer science and electronics. So there is a possibility that you might not heard about this organization. So ASTM International is standard development body similar to IEEE or ISO. So we develop standards for more than 150 different industry sectors with multiple technical committees with representation of over 34,000 members who are in fact developing these standards. So we developed around 13,000 standards. That includes standards all the way from petrochemicals to the testing of materials that we are normally doing in our mechanical engineering labs, material specifications, all different things. As I said, we serve more than 90 industry sectors, and our standards has been implemented across the globe, and we have 125 memorandum of understandings with different national standard bodies, like in India, Singapore, and all different places. The way in which we work is primarily based on the accreditation or the principles of World Trade Organization, which sets some requirements to be a standard body. And most of these standards are adopted across the globe for different applications. And standards are developed based on a consensus approach, meaning industry experts are part of the standard development activity, and they discuss what is needed as part of an industry requirement, and they draft the standard. The standard will be reviewed across all the different members in the company. And at the end of the day, everyone should agree that whatever is written in the standard is agreeable and it is applicable globally. So, having said that, we have been working in specific areas like advanced manufacturing, and that's where my focus is. So today, what we are going to discuss is primarily on the advanced manufacturing state of the art, understand cyber physical system components, and how cyber physical components are getting integrated into the advanced manufacturing, then identify some of those common threats and vulnerabilities in cyber physical systems, and know practical risk assessments, defensive controls, and incident response systems, have a prioritized roadmap and checklist to improve your cyber physical security. So this is the objective of today's discussion. And what we would cover here is primarily a detailed overview about advanced manufacturing and the cyber physical systems, threats, vulnerabilities, and real world incidents. We talk about risk assessment, threat modeling, then different control mechanisms that we can adopt in advanced manufacturing, how to monitor, detect, and report those incident responses. Finally, how to govern this entire thing, workforce development, and the future roadmap. So this is going to be the overall discussion points in the next 45 minutes to 1 hour. Okay, so before getting into the details of cyber physical security and how they are embedded into advanced manufacturing, I just want to walk you through the evolution of manufacturing. Then only we can come into the point of advanced manufacturing, or what is happening right now. So we know we have industrial revolutions happened all the way from 1784, even today. And those industrial revolutions were categorized as Industry 1.0, Industry 2.0, Industry 3.0, and currently we are into Industry 4.0, where we talk about cyber physical systems, we talk about Internet of Things, we talk about networks. We are into different kinds of manufacturing, where we again call this advanced manufacturing as smart manufacturing, or we call it as digital manufacturing, or we call it as factories of future. So there are a lot of terminologies flying around, but in Industry 4.0, it's primarily what's happening is that equipments communicate among themselves. Then they have codes and systems in place that integrates these systems to make sure that a particular work can be done. So in Industry 4.0, the primary idea is to connect all these different systems seamlessly so that you can improve your productivity. Now we are moving towards Industry 5.0. That is the next step. So we are evolving into that area. And in Industry 5.0, it is more human-centric, where things are taken care based on sustainability, standardized methods, then communication between these machines without having any human interactions. So all those things are going to happen as part of Industry 5.0. We are now marching towards that. We are not yet into that level, but that's the next focus. So right now we are in the world of all these different systems connected together. Now we are going to the world of sustainability, human-centric activities, personalization and collaboration with machines. So in Industry 4.0, machines were the main aspects, whereas when it comes to Industry 5.0, we are going towards human-centric initiatives. But all those things are now governed and managed by data, managed by Internet of or IoT, that is Industrial Internet of Things. So this is a combination of all these different technologies that moves us from Industry 4.0 to Industry 5.0. So what is advanced manufacturing? Again, as I said, there are so many terminologies going around: smart factory, factories, factory of futures, all these big conglomerates having their own facilities with automated features. So advanced manufacturing is nothing but an integrated, automated production using technologies such as robotics, 3D printing or additive manufacturing, digital twins, IIoT, cyber physical systems. You can see all different things here: big data, data analytics, augmented reality, artificial intelligence, machine learning. All these things are part of your smart factory concept. And one common thing that you can observe here in this smart factory setup is that there is a digital thread that connects all these different areas, no matter whether it is big data or the physical systems or the robotic processes. There is a digital thread where you have data traveling seamlessly across multiple links. So digital thread, in fact, forms the backbone of advanced manufacturing. Now it comes to cyber physical systems. So cyber physical systems means it's again a broader term. It's not a single entity. So it's a mechanism controlled and monitored by computer algorithms, which are tightly integrated with internet and its users. And these systems, in fact, integrates your computational as well as physical processes. So when I say computational, it is primarily your information technology aspect and your physical processes. So physical processes involves all these different sensors, controllers, actuators, networks, human machine interfaces, and the actual production machines. That production machines could be an additive manufacturing machine or a 3D printing machine. It could be a robot. It could be a latest machining center. So these are all the elements which are part of your cyber physical system. So previously we have IT security. Whenever we talk about IT or security, we just focus on IT security alone or information technology alone. And when we talk about OT or the operation technology, we just talk about that part alone, because both have two different scope. So IT in information technology, you will be primarily focusing on systems, data breach and things like that. And in OT, it is primarily about the machines or the equipments that really manufacture the parts. Mainly, we need to make sure that those machines are continuously working. There are no issues with all the softwares involved in the machine. So we take care of that thing separate, and we take care of IT separate or information technology separate. So the security concerns will also change with respect to your IT as well as your OT stuffs. But when it comes to advanced manufacturing, you cannot keep these two things separate anymore, because in advanced manufacturing, you have both the IT and the OT. They are interlinked. They are merged together. That makes things more complicated. And that's what we will be discussing in the coming slides. So when it comes to the infrastructure of this CPS or the cyber physical systems, you can see there are multiple layers. If I go from bottom to top, you can see some like field or OT layer that includes sensors, actuators, PLCs, and robots. So previously, as I said, this was treated separately, and the next layer is the control layer. So that's where your human machine interface systems as well as your manufacturing execution systems are placed. So they are the one who in fact control the OT layer, or they are the one in fact control the actuator, sensors, and things like that. Once you have that manufacturing execution system or the control layer, then the next layer is the edge layer. That is the place where the edge computing or whatever processing is required within the system ends there, or it is a gateway from or the point where you are transferring the process data
Excuse me, Rafi, sir.
ERP or your cloud.
Excuse me, sir.
Sure.
Sir, I think it is in presentation mode from your end, but still
Yes.
we are seeing the first slide itself, sir.
Oh, you're not seeing the slides?
No, sir. No.
Oh, I'm sorry. In that case, I have to go back and then. So you are seeing this screen right now, right?
Now, yeah, this PowerPoint screen is actually what we are seeing. And now
Not
its second
more
slide
than-
is visible for us.
Okay, so far you were hearing from only the first slide. I was not
Yeah.
scrolling others, right?
Yeah,
Oh,
yeah.
okay, so I'm not knowing about that.
No
Anyways,
issues. Okay.
I'll just quickly get through that. So what I was mentioning about what ISTM is, I don't want to repeat what ISTM is. Okay, get into other points like the learning objectives that also I've told. We'll be talking about advanced manufacturing, state of the art, understand the cyber physical system components, identify common threats and vulnerabilities in cyber physical systems, practical risk assessments and defensive controls, and the incident response steps. Then we'll be having a prioritized roadmap and checklist to improve the cyber physical security. So this is the learning objective that we are going to have from this presentation. Then the next part is what is going to cover. So we will be covering advanced manufacturing and an overview of cyber physical systems, threats, vulnerabilities, and real world incidents. We also cover risk assessment and threat modeling, how we're going to do it for advanced manufacturing. Then different controls that we are going to implement. That includes architecture control, network controls, device, supply chain. Then kind of monitoring the systems, how you detect some of these threats or changes, then how you're going to respond to those incidents, then governance and workforce roadmap. So this is what we are going to discuss as part of this presentation in the next few slides. And I was talking about manufacturing evolution. I know that you guys didn't see this slide, but again, I just want to quickly mention about what I was talking about, Industry 4.0, and how Industry 4.0 is now moving towards Industry 5.0. So before getting into Industry 4.0, we have so many other industry revolutions happened in the previous years, and now we reach the point of Industry 4.0, which is governed by cyber physical systems, Internet of Things, networks, and different advanced manufacturing components. So the advantage here, or the characteristics of Industry 4.0, is that here we have all these different machines interact among themselves, and they can even take decisions at some point while performing. And the human intervention in this case is relatively low, even though we need operators who can manage it from externally. And there is also capability to run these things, run these machines remotely. So these are all the capabilities of Industry 4.0 with the integration of cyber physical systems. And from Industry 4.0, we are moving to Industry 5.0, which is still evolving. So when I say Industry 5.0, it is primarily the next phase of industrial revolution, where we talk about sustainability, we talk about standardization or personalization and things like that. So we are moving toward that direction. But again, all those things are going to be governed by our developments in artificial intelligence, machine learning, and things like that. So coming to advanced manufacturing, we talk about the definition of advanced manufacturing, what it forms, or what are all the elements of advanced manufacturing, and there are different terminologies people use as part of this. One of the common terminology is a smart factory. So from the word smart itself, we can see that these machines are integrated and they can communicate among themselves. And if something goes wrong, they can give a response. So you don't require to be there as a human. You don't require to be there in the factory to run it. You can do things remotely. You can get, or you can see everything in a dashboard, what is happening, and you can take decisions based on that. And one key thing I want to emphasize here is all these different things that you're seeing here, like IoT or additive manufacturing, big data, supply chain, all these things are connected by a digital thread. There's a seamless flow of data across these different lines. So that forms the backbone of advanced manufacturing, where we are handling data. So that is the key thing whenever we discuss things about advanced manufacturing, that involves different manufacturing processes, different methods to analyze the data and things like that. So getting into cyber physical systems. So today we are talking two different things. One is the advanced manufacturing, and another one is cyber physical systems, and how these two things get integrated and becomes a problem, or how we are going to manage security in this instance. So in cyber physical systems, so the definition itself is, it's a mechanism controlled and monitored by computer algorithms, tightly integrated with internet and its users. So previously we only say cyber security. Now what we are saying is cyber physical security, because we are now converging two different aspects. So previously we have only IT, IT security or cyber security for IT, or cyber security for OT. So IT is primarily managing your data, your systems, etc., whereas OT is primarily focused on the real machines, the real equipment on the floor that is controlled by PLCs, sensors, actuators, etc. So with advanced manufacturing, what's happening is that this cyber physical systems that converge IT with OT and making it as a single system. So that's where we are discussing about the security issues in advanced manufacturing when you link all different systems in one network. So I believe we were in this slide, we are discussing this slide on the different architecture and key components for the CPS. So here you can see there are multiple layers in this one. And the one at the bottom is your field or OT layer. This is where you have all different machines and the corresponding sensors, actuators, PLCs, and everything rest. So whatever you are getting from here, that need to be transferred to the next layer, that is your control layer. That's where your human machine interface or manufacturing execution systems, everything occurs. So that's the layer which controls your data from sensors, actuators, and PLCs. And control layer, the next step is once you have the control mechanisms, or once you have the proper data, everything, the next thing is processing that data in your edge layer or in your edge computing one. So whatever is possible, you will be calculating and processing at that layer itself, or that edge computing layer itself. And once you have the processed data, once you have that information is now moved up to your IT or enterprise level. That you can do data analytics, or you can do, or you can take business decisions based on whatever information that you get out of this edge layer. So you can see there are 4 important layers, and all these 4 important layers are interconnected, and you can see data transfer happening from one layer all the way to up. So when you see this, you can see a possibility of different data breaches or different risk while you transfer this data from your field layer all the way to your enterprise layer. So why it matters? Why cyber physical security matters? So these safety, or if you're not having proper safety in your cyber or CPS, this will risk not just the workers alone, it will also risk the public. You can have a production downtime and end up in revenue losses. Then you'll be having a damage of your physical assets itself. You might be spending crores and crores of rupees in those physical assets, but these cybersecurity threats could take away those machines, or you can even bring down the machine. Then IP losses, whatever that you created with research over the past few years might get lost. And you should also have regulatory and legal implications if you're not following the procedures, and if you have any possibility in data breach, then you are liable, and you have to comply with the requirements from the regulators. Then it also affects your reputation. So there are a lot of different things that would come up if there is a cyber security issue. So who are the ones who do this primarily? From a broader perspective, you can put it into 4 different categories. One is your cyber criminals, who are ransomware operators or financial attackers. Their motive is primarily to get some money out of it. Then the nation state actors. This is primarily between larger organization, not organization, between countries. They want to stop the progress of another country. They want to stop the infrastructure. For example, it's primarily on nuclear and other defense areas. Then other set of threat is coming from insiders itself, that is from malicious ware or by negligent employees who don't care about maintaining all those safety protocols. Then another threat comes from your competitors and the supply chain. It includes third-party compromises or even competitive espionage to get your data, to get to know what you're doing, or to even halt or sabotage your existing manufacturing systems. So these are all some of the source of threats that can happen in your advanced manufacturing sector. Now, getting into the next one, that is your typical vulnerabilities and attack surfaces where these kind of attack would normally occur. So we have devices which sometimes we don't care about its security. So we have a lot of unpatched devices, even though there is a security failure. We might not take enough care in fixing that up, as well as issues with your firmware. Then default or weak credentials in your program logical controllers, or in your human machine interface, or in your SCADA. Then lateral movement from IT to OT via flat networks, because you don't have any hierarchy between the networks. You even communicate between your IT infrastructure and the OT infrastructure in a lateral movement without having a serial or without having a hierarchical way of controlling it. And also have insecure protocols and plain text communication. Another aspect is exposed to remote access and third-party connections. So these are all potential attack surfaces, which one company should be aware of when we design your cyber physical systems. And another aspect is the lack of segmentation and asset visibility. You will be having a lot of assets, and you might not have grouped that assets or segmented into different groups based on its vulnerability towards attacks. So these are all some of the attacking points that the cyber attackers or whoever want to sabotage your physical systems. So these are all the options, or these are all the points where they can that allows them to do that kind of an activity. So here's some example of these kind of attacks happened right from 2010 all the way now. So one of the very famous attack on a physical system is back in 2010. It was called StackNext. And it's a sophisticated malware. It's a malicious computer worm that is transferred to an Iranian nuclear centrifuge by modifying the PLC logic while displaying the normal operation. So what it does was it get into their PLC and made the code in such a way that it shows everything is working fine in the output, but at the same time it changed the code in such a way that the machine will be actually down. It might not be operating properly, but in the human machine interface system, it shows that it is working nicely. So this was the first known cyber weapon designed to cause physical damage, and it was not even via internet. It happened by they used thumb drives to transfer the data. So it was not even via our existing or current data thread or anything like that. So this thread was directly on the machine to attack the PLC. The PLC is not connected to the internet. The PLC is a single entity, and in that one, they transferred this malware via a thumb drive. So this is the first known cyber attack. And the lessons learned is that even though you make it independent from your net, still there's a possibility to attack your physical systems. Another example is on this happened in 2017. There's an attack called Triton, and this is primarily to sabotage a safety system, and that is designed by Schneider Electric, and one of their safety controllers in a petrochemical facility at Saudi Arabia that was got attacked. And so what happens is that even though something goes wrong, actually the safety system should trigger. So because of this attack, if a failure occur in the system, still the safety system didn't get triggered. Okay, so that is another way of another attack that people have done before. Then until now, you have a lot of ransomware attacks on manufacturing organizations. So these are all financially motivated. What they do is they stop the production. They put this malware so that they stop the production of their facility, and then they demand a huge amount of money so that they will reset the manufacturing facility only after getting that money. So that's the manufacturing ransomware wave. It happened to multiple organizations from 2019 until now. Then apart from that, there are so many other supply chain compromises, meaning you work with different organizations, and when you work with different organizations, there are points where your third-party supplier would not be taking right care, or they may even compromise some of the software that they provided to you, or when they do an upgrade on the software, there may be some missing patches, or there may be some kind of issues with the software. So those kind of third-party compromises would also affect the entire manufacturing system that you have. So these were some of the things that we were seeing before. Now, how this is affecting your advanced manufacturing. So whatever we have discussed so far is the generic impact of cyber physical systems when it comes to a security threat. Now, as I said, cyber physical security system is part of advanced manufacturing ecosystem. and anything happening to that cyber physical system will badly impact advanced manufacturing. So when I said advanced manufacturing, it could include any kind of advanced manufacturing systems. It could be additive manufacturing or 3D printing. It could be robotics. It could be an advanced machining center. Whatever it is, it got completely affected if your cyber physical system or your digital threat is affected or get a security issue. So this image shows an advanced manufacturing workflow, and you can see there are two different phases here. One is your design phase, and another one is your manufacturing phase. Now, all these latest manufacturing techniques, they start with a design of the part, and the design is done by a team with using your CAD software or your constructed solid geometry, CSG modeling, and then it is passed to FEA or finite element analysis. So this finite element analysis is done in a computer, and that is then saved in your FEA database. Now this files will be transferred to a software that connects it to the actual machine, and that software is doing the pre-processing of these files so that you can make it ready to get produced or get printed in your machine. So in this case, you can see here there's a tool path. So this software determines the tool path to be created in order to produce that particular part. Okay, so all those things you can see, these are all containing data. So any manipulation on these data could impact your part. So at every stage, you can see there is a possibility for a threat, and you need to identify what it is. So next, getting into the actual machining. So again, these files will get into the manufacturer platform, and from there, you can remotely send it to another machine to print it or to manufacture it, and there'll be an operator there. So most of the cases, in the current way, the operator might not have any direct access to the actual content of the file. So he can just run the file. He might not be able to do any kind of manipulation on the file at this point from an operator perspective. But if someone wants to do that, they can still do it. But when someone is really operating the machine, at that point, he cannot make any changes to it. So once that is done, you can see you are getting into different test protocols. That is your manufacturing phase, and you can see there are multiple manufacturing methods shown here. So no matter what the manufacturing method is, up to this point, you are getting a digital flow of files, and when it comes to machine only, you are getting your actual part. Okay, so until then, it is full of a digital data flow. And now when it comes to inspection, that's the last phase, that also contains data. So all these different inspection methods that can be tampered if someone wants, and the data can be different. So rather than saying that this particular part got certain dimensions and it can be approved if that is the dimension, and if someone changes that criteria, even for a part that is not good to go, they will say it is good. So like that, people can make changes, people can make edits and modifications to these files by wrongly accessing it. So in earlier days, you will not be using a digital file to manufacture. You will be taking a part, you'll be having a tool, you use the tool to manufacture it. So you are not going to make any changes, or you cannot expect anybody is going to hack your part, because you are the one who controls it, you are the one who manages it. But right now, that's not the case. When you have this design phase and manufacturing phase, everything combined together, and it is managed by a digital thread. So I just want to emphasize the fact that previously it was two different systems, but now you have this digital and the physical combined, so that whatever happens in your digital will get flowed down into your physical systems as well. Now, here what I'm showing is the attack surfaces for a 3D printing or an additive manufacturing workflow. In the next couple of slides, I'll be mentioning only additive manufacturing or 3D printing primarily because it's easy for us to comprehend what is happening at different phases, because 3D printing technology is primarily one which mostly uses this digital thread, because there is no tool used in 3D printing. You're not creating any tools, or there is no mold or anything like that for this. So to begin with, as in the previous slide, you can see a design step, you can see a pre-processing step. So in the design step, you are creating CAD files. Then in the pre-processing steps, what you do is you take the CAD file and that your machine can understand. So that's called a slicing or pre-processing. And after pre-processing, you will be sending it to your machine, where the machine got a firmware, and that firmware can understand what it needs to be done using that data it received from the previous pre-processing stage. So once it have that, then it get into the actual printing. So that's a place where you only have actual printing, and there is no digital data going in. Digital data is going in, but you are not connected to any other external systems. So in printing, the printer itself got some sensors and things like that, but other than that, it is not directly connected to any other facility. So, but here you can have controllers. You can have different thermal controllers. You can have different controllers to measure the temperature, and that can be again fed back to a system to take a decision whether the temperature is right or wrong, whether the machine is working right or wrong. From there, it get in the next stage called the post-processing, meaning after you print something, then you need to do some kind of surface modification. That's called post-processing. And from post-processing, you'll be going to the QA or quality assurance systems. So in all these stages, you can see there is a critical touch point where things can go wrong, or if someone want to make some modifications, or if someone want to do some changes, they can definitely do that. Okay, so the critical touch points here you can see are the CAD files itself, or the sliced models, the firmware, the build parameters. When it comes to hardware elements for this machine, things like print controllers, sensors, network interfaces, the physical media that you use in order to transfer the data, all those things are potential sites to attack. And the external attack vectors include remote services, because in 3D printing, one of the advantages is that you can do distributed manufacturing, meaning you can have just one file and use that single file to print a part at multiple locations. You send this file over internet to that particular system, and then the system can print the file or print that particular part. Even though it sounds easy, but when it comes to the security aspect, there's a big risk there. One is the IP risk, that anybody can store that particular file. Second thing is the tampering. Somebody can tamper the file, and you will end up in a different design. After manufacturing, you're getting a different product. So these are all the things that could happen when you remotely connect to a machine. Another thing is the supply chain, meaning the organizations who are providing you materials or providing softwares or equipment, firmware, when they do updates to that also would affect ultimately to the final part quality. So overall, this additive manufacturing or advanced manufacturing systems introduce unique cyber physical security challenges at each stage of this digital thread, from design all the way to production. So which means we need to be careful about all these different stages and what's going to happen at all these different stages, and what kind of measures that we need to take at different stages to make sure that at every point it has been passed without any issues. So some of the primary threat categories, in fact, the first three are normally for your IT, normally for the IT security, that is the confidentiality, integrity, and availability. So the confidentiality primarily look for the IP theft in this case. In the case of advanced manufacturing, it is about the IP theft of the CAD files that we created. For every organization, the files that they create, the designs that they create is proprietary to them. It is their intellectual property, and that could get lost by this attack. Then that's a confidentiality part. Then the next part is the integrity. So people can unauthorizedly access the geometry, or they can make some changes to the parameter, causing weakened parts. So as per the design, the part should look nice, but if someone changes the actual process parameters, that could end up in getting you a weak part. Third thing is the availability, because if your system is down and if it is not available for production, then obviously it is going to disrupt your entire manufacturing system and their production system. So whatever was applicable in IT security is now applicable for manufacturing security as well, and advanced manufacturing security as well. On top of these three, there are two more things specifically for advanced manufacturing. That is your physical safety risks as well as the supply chain. So if you tamper a part, if you tamper the process parameters of a part, and you go with or you produce a wrong part, that could physically harm the end user, or it could even cause some operational incidents. Similarly, the last one is the supply chain risk, where you can have compromised materials, compromised firmware or third-party components. So these are all additional security threats that you can see in advanced manufacturing when it coupled with the current infrastructure. So we can see that the kind of threat is even bigger when you integrate these IT and OT segments. Then what is going to happen? So what's the impact in these cases? These are some of the potential consequences of security breaches in advanced manufacturing. One is, as I said before, your failed or weak or failed critical parts. So you can have safety incidents because of compromised structural integrity that leads to equipment failures. Because imagine if you are producing a part for an aerospace system, the criticality is very high. And if such a part is sabotaged by changing its parameter, and if you put that part into service, obviously it's going to be catastrophic. Then silent degradation. That is, when you print a part or when you produce a part, the part still look good. You will not be seeing any big quality issues. So most of the time, these quality issues get undetected unless once it happens during its actual operation. So there's a silent degradation of the part. Then you lose your IP. So if you have done multiple years of research and produce something, and all of a sudden, if someone is taking away those designs, then that is a big IP loss. Then production downtime for big systems, for large manufacturing premises. If there is a small outage, if a small system outage, that itself will enter into huge financial losses, because your entire system is going to be down, and you are not going to produce anything for until you get that system back. So production downtime is another impact due to this security issue. Then regulatory non-compliance. That means if you are not in compliance with your regulator, then you will end up in paying penalties or lawsuits, or even certification losses. Sometimes all these organizations will be certified by third-party organizations, and if there is a product failure due to these security issues, then they are responsible for that. And that cause some legal issues to them. These regulatory non-compliances and all those things create a lot of issues when it comes to the security aspect. So even though advanced manufacturing is considered as is highly productive and highly efficient, but it also comes with huge risk, which you can see with these impacts. So some of these threats, we already saw some of the threats in the general CPS systems. Similarly, for advanced manufacturing, there are similar threats that includes nation state actors, and they are the highest ones. They use sophisticated operators with extensive resources and target strategic manufacturing capabilities such as defense or even nuclear centers. Likewise, we have competitors. The kind of threat the competitors bringing in is not that high, it is medium. So primarily, they want to slow down your progress. They want to take your IP and copy that IP. So that would affect some kind of an economic advantage, a disadvantage for you and advantage for them. Another one is that cyber criminals, they are again like the ransomware softwares. They want to halt your system for a while and they demand a lot of money. And you know that if your system is down for few days, it's going to affect your overall productivity. So at the end of the day, you're forced to pay the money and get that right. So for advanced manufacturing, as I said, these are the 4 important things, and obviously you have threats from your employees, and that might not be intentional. They may be careless in working with those machines. That would give an external party or external person to get into your system. Then hobbyists and activists or ethical hackers, they want to see what's going to happen if they introduce or they try out something like that. So those threats are relatively lower, even though it will halt your production or something like that for another days. But their intention is not to take away your IP or to completely shut down what you're going to do. So these are some of the threats that advanced manufacturing is facing from a cybersecurity perspective. Now, how we can identify these things? So traditionally, we can use the same risk assessment that we are performing in other activities. The approach here is that you have a lot of assets. You should identify all different assets and see dependencies, meaning to what systems they are connected to. So a given machine might not connect to the entire cyber physical security environment, but you have to see which asset is connected to which systems, and then you determine the threats and vulnerabilities of those identified assets. Then what would be the likelihood and impact if that particular asset got impacted or got this kind of a security attack? Well, it could be safety, or it could be operational, or it could be financial impact. So you should assess that and the likelihood and impact, meaning what is the likelihood of that occurrence, or how often it could happen. And if it happens, what is going to be the impact due to that? So that is a part of the risk assessment that you need to identify for that asset. Then you prioritize those risks, because you cannot have the same level of mitigation measures for all the risk. So you have to prioritize which is the highest risk, and then you define the mitigation strategy for that particular risk. Then you monitor it and reassess whether the risk still exists. So this is a circular process. It keeps on going to see you mitigate the risk related to a given asset to the lowest possible level. And there are some industry best practices that people use. They use this risk prioritization metrics that will help you to identify which one is having the high priority and which one is having the low priority. Accordingly, you can design what kind of strategy that you can take with the involvement of your cross-functional teams from operations, engineering, IT, and security. So this is the first step before we go into the real security measures. So first you need to do the risk assessment, and once you did that risk assessment, the next thing is you assess the inventory and the criticality analysis, because for different applications, so for different elements, your criticality will be different. Okay, so you have to maintain an OT asset inventory in order to identify the criticality of those assets. For example, you have to maintain the details of the device type, the firmware versions, because this firmwares keep on changing every year or once in 2 years. they may update it. So you have to make sure that you captured that version. Then the kind of network interfaces and the business function of that particular asset, as well as who is owning the asset. So you have to maintain that inventory of your asset. So here's an example that I gave in the right. So for example, if it is a PLC, you should know what is the function of the PLC and who is going to own that PLC. And if something happens to that PLC, your criticality is going to be high. So this kind of a listing need to be done with all these different assets that you have, whether it is PLC or whether it is your sensor or robot or whatever machine that you're using. You should have this kind of a asset inventory which categorize the criticality of those things. And you can also perform criticality scoring based on safety criticality or mission criticality, or if it's a production criticality, or if it is a IP rich file or format, or if it is a single point of failure. For example, if that particular asset got failed, then it is going to cause the failure of the entire system. So all these things need to be considered when you perform a criticality scoring, and this criticality matters or varies across different organizations based on where they work and how they work. For example, when it comes to an aerospace company, for them, safety is more important. So when you have a product and if something happens to any of this system and it is going to affect the safety of the product, that is going to be the most important concern for them, rather than the number of production losses. Okay, so depending upon the kind of organization or industry you work, you need to have a listing as well as a definition of the criticality and provide scoring according to the different criticality levels. So once you have that inventory list with all these different criticality levels, then you can model for you can do the threat modeling for advanced manufacturing. So you can use you can perform a use case focused threat models, meaning you can think what could an attacker do in order to cause safety harm, or what could an attacker do in order to stop your production. So you can think from an attacker's perspective and see what are the things that we can do. So again, as I mentioned in the beginning, in the previous slide, so you have to identify the assets. So what are all the assets that this attacker could get access to? So for example, CAD files. So CAD files are the one which is having all the information about your product. So if there is a small change in the CAD file, if you make a small change in the design, or let's say a tolerance value or anything like that, that could severely impact the final part. Then the machine firmware, you have to make sure that the machine's firmware is not easily accessible. So like that, you have to see which are all the assets that are critical. In this case, in the case of additive manufacturing or 3D printing, we can have files, the machine firmware, the print controllers, the material software that we have, and the qualification or quality assurance record. These are all the assets that we look at when it comes to that particular manufacturing process. So once we have that assets, then the next step is you map the entry points. What are the locations, or in what way this attacker can access these different files? So once you identify those map entry points, then you can define the trust boundaries. You can document the security assumptions about trusted components. You can have a database about trusted users who can be given access to these files, the frequency of those access. All these things you can define based on your mapping of the entry points to different assets that you identified. So here's an example for a threat model that I mentioned here. A malicious CAD file from an external supplier could be a threat. So the file might contain a malware that could run in your machine. Then a compromised firmware that updated distribution. Again, when a machine is upgraded or a machine's firmware is upgraded, that could get compromised. Similarly, infected print controller that would affect multiple builds. So these are all some examples that you can see that would affect your manufacturing process chain or advanced manufacturing process chain. Then when it comes to very specific attacks on advanced manufacturing, or in this case, I'm talking about additive manufacturing, it's like the tampered CAD, parameter tampering, firmware or driver compromise, then supply chain insertion, where you can include contaminated materials, altering the physical properties of the printed parts. Then side channel interfacing, meaning you can have thermal emissions that can, or thermal camera that can leak information about designs. So there are so many ways that people can get these information out of your systems. So one of the critical insight from these points is that many of the advanced manufacturing attacks are very subtle and very difficult to detect. You cannot detect it through visual inspection, or there is no specific test methods that can be used on each and every part to see whether the files got tampered or whether any part of the machine got tampered. So most of the time, the physical properties of these kind of compromised parts will remain unchanged. But there is no way we can identify whether is there any change in future due to this tampering of parameters and things like that. So there are three attack locations. One is the design phase itself, people can do something on it. In the pre-processing phase, people can make changes to that. And also during production, where you can manipulate the process parameters, or you can manipulate the sensors or controllers. So these are all some of the attacking areas for advanced manufacturing that you can visualize. And another important aspect again is that the detection challenges, which I mentioned this before, but most of these things cannot be visualized that easily, cannot be identified that easily. Small integrated changes in the parts are very hard to detect. With the change in parameters, there would be a change in physical properties, but it is hardly detectable. Similarly, there are limited forensic artifacts in advanced manufacturing workflows, because most of the time the build logs may be incomplete and the physical evidences often requires testing. So particularly destructive testing, that is time consuming and it's a costly affair. So we don't create that many number of artifacts because it is costly anyway. So that's another challenge. Then there are few standards, not many standards are available at this point in order to compare and then validate whether the part is authentic or not based on these changes in the parameters. And these IP and liability concerns limit information of sharing. So even though something happened in one organization, they will not share it with another organization that such kind of an instance happened because of IP and liability issues. So there is no previous record, or there is no shared data that is available for us to understand what would be a possible instance, or what would be a possible outcome because of the changes, because of tampering all these different files or tampering different stages in this additive manufacturing workflow. So how to mitigate the risk? So we know that there is risk now. We know that there are different locations where these cyber attackers can influence and make changes. So what would be the next step in that case? How we are going to mitigate that risk? So one strategy is that you have to have a defense in-depth strategy, meaning you should have multiple layers of defense, reducing risk by providing redundancy and minimizing attack paths. Then you should have physical security and access control, network segmentation, and micro segmentation. We'll be discussing that in detail in the next slides. Then device hardening and secure configurations, application of protocol controls. All these things can be applied in a fashion that you can minimize these risks as much as possible. And the last one is governance, training, and supply chain control. That's the last one. But before that, we should keep all the defenses first. And then comes the awareness, governance, and training. So the first one is the network segmentation and secure architecture. I mean, in an earlier slide, we talked about all the 4 levels in the cyber physical security. And you need to segregate each level with required firewall. So even though something happens in the lowest level, it will be held in the lowest level itself. And there is one standard ISO, there is IEC 62443. This standard gives some basic understanding about what need to be done in terms of securing all these different layers in the network. Then another one is secure communications. So you can apply transport level security so that you can have encrypted data as well as certificates. Then use mutual authentication for remote devices. If you are allowing someone to access remotely, then you have to have mutual authentication. Ensure secure firmware signing and update pipelines. You protect your credentials and keys with hardware roots of trust. So it's basically you have to implement cryptographic concepts in your communication between your assets. Then device and endpoint security. Here you can perform a device hardening where you disable unused services, you change the default credentials, you apply secure configurations, and the patch management, meaning you test and deploy your firmware, and whenever required, you have to make sure that the firmware patches has been provided or have been done in a staged manner. Then baseline and integrity monitoring, where you have strict protocols in maintaining your file integrity and behavioral baselines. And whitelisting and application, meaning you have to come up with a list of people or a list of agencies or list of your customers who can be provided access to your systems. Okay, so this is another mechanism to make sure that you put some control in the different levels of your CPS. Another one is secure development and supply chain security. So in the very beginning of your design itself, you should include your security measures in the design. For example, you should have a proper threat modeling in the beginning of your or during the design of your system itself. You should have secure coding and standards to be used in order to come up with those secure designs. Then you should have validated third parties. You should have proper contracts in place to make sure that they are not violating any of the requirements. And even though if you give them access, you will be they'll be maintaining that access properly. Hardware and firmware authenticity and its integrity. Maintain your software bill of materials for all the critical components that you use in your advanced manufacturing. Then comes monitoring, detection, and incidents. So continuous monitoring is another important thing to make sure that you are not leaving any space for anyone to attack the system. So you monitor it, you detect it. When you find it, you have a proper mechanism to respond to that incident. So you should have a procedure in place for such kind of responses. As an evidence in the future or for future references, you need to maintain your logs, your evidence handling, and the forensic imaging, that image processing that you have done. So all those things need to be kept, because you are not going to get this information elsewhere. This is your IP. This is your information from your own practice. So you maintain that for traceability, so that in future, if something similar comes up, you can always go back and see if this is something similar, so that you can take steps accordingly. Then comes the governance, policies, and workforce. That's the last one. After putting all the defense in place, now you need to have some governance in place, that is assigning your OT security ownership, integrate it into your ERP management, your enterprise risk management. Then you should also come up with policies like remote access policy, vendor access. So for you cannot simply provide access to everyone. You should have policies in place that who can give access to what. Similarly, training. People should understand how different cyber attack would come. So we need to have continuous training for people who are using these machines, who are working on any of these part of advanced manufacturing, to understand what kind of phishing or what kind of cyber hygiene that we need to maintain in order to keep the system, because employees are the first level of defense. So if they can understand what is needed, what is required, then for a certain extent, they can control some of these threats. And the last one is your cross-functional committees. This is not the responsibility of one particular department. So you have IT security team, you have operation team, you have engineering team. So we need collaboration between all these different teams to see you are not giving any loopholes to get your network vulnerable. And finally, you can also come up with a roadmap or a checklist which helps you to implement whatever we discussed in your system. It need not be a industry even. In a college or in any organization, if you have a system like this, or if you have a cyber physical system or a manufacturing system, then you can implement this roadmap that includes multiple things like, you can update the asset inventory that we have mentioned previously. That's the first step. Takes only 1 to 3 weeks. Then implement immediate segmentation. That means you need to separate your IT and OT networks, isolate your critical systems, and put a required firewall in these different networks, and then enforce remote access controls. You change the default credentials and implement multi-factor authentications. Secure vendor access. Don't give permission to all the vendors who are working with you. You have to have that things to be developed, and you should have the procedure to enforce who can access what. And you should have a baseline monitoring for critical process lines. Prepare your reporting playbook and run a tabletop, meaning whatever responses that you get after each issue, then you need to document it and exercise it with your rest of the team. Then secure update process and vendor reviews. So this is based on establishing your software patching procedures, your vendor security assessment processes, and firmware and software update pipeline. So this is an ongoing process. This is not going to be a one-time event. This is a continuous one. So this could be something which any organization or any manufacturing firm can adopt to see how they can manage or how they can mitigate the risk that they may get for their cyber physical security systems. So the emerging trends and future, everybody know that we are in the world of AI and machine learning. So we have increasing convergence of AI and machine learning for anomaly detection and predictive maintenance. So by using these AI techniques, we could be able to identify those small variations or those changes so that we can easily identify what went wrong in the system. Then you can grow using digital twins to simulate attacks and resilience. So you can use digital twins to create those physical models. What happens if there is an attack occurs? Also, regulatory pressures and standard adoption. As I said, there is only one standard at this point. Then that is IEC 62443. But there are other standards coming up. We can use those standards as the baseline to work towards keeping the security in place. And the last one is about the standardization and regulatory landscape. As I said, there are not many standards at this point. Standardization is evolving. But the immediate one that you can refer is IEC 6.2, gives a basic understanding about the security requirements needed for an automation control system. And IEC 27001, again, it is a generic one, but you can have some basic concepts derived from this particular standard, even though it is not exclusively for CPS. Okay, so some of the key takeaways are CPS is mission critical. It affects your safety, it affects production and reputation. You have to start with your asset visibility and risk prioritization. That is really important. You should know what assets that you have and what is the risk involved with each of these assets if it is exposed to someone. Then use defense in-depth segmentation, device hardening, secure communication and monitoring, and prepare response playbooks and practice them with operations. Prioritize quick wins and gradually build your maturity in defending these security threats. Okay, so how the future look like. As I said, we have artificial intelligence, machine learning, everything right now available. That is definitely going to shape the way at which advanced manufacturing is going to proceed. So I just want to show you a quick video. Okay, so that's all from me. As I said, it's going to be a trusted manufacturing, advanced manufacturing coming up. So we need to make sure that that trust need to be prevailed by implementing the right cyber physical security systems in place. Thank you so much for your hearing. If any questions, open to that.
Thank you, Mr. Biswin V. Sharif. Lecture was very interesting. But I have 2-3 questions with you actually. Is as far as the physical security concerned with the data centers, you are just pertaining to manufacturing, etc. You are told. Generally, for the data center, there is 2 types of data center. One is underwater sea data center as well as offshore data centers. So, what type of physical security we have to make to be very much strong?
So the data security I was talking here is about the physical systems within an organization.
Yes, yes. That's what I'm saying you. What type of security we can have for the data centers, particularly for government sectors, e-governance. We have a lot of data centers that are available. So all type of users are coming, going. Okay. Any idea? No. If you have idea, you can share. There is no problem.
I don't have anything related to that when it comes to data centers specifically.
Anyway, you told about the manufacturing sector.
Okay.
So in that sense, the same scenario I'm asking. They are all cyber security only. Maybe a software cyber security or anywhere hardware, physical security.
Yeah. So previously we have only cyber security. That's the reason why we have this convergence of cyber and physical security. Okay.
Fine, sir.
So when these two things converge,
Sir, you are from industry, sir. You are from industry or you are from academic?
I am from industry.
Definitely you will have some knowledge. That's why I ask you.
Yeah. So again, as I said, our focus is primarily on manufacturing systems within organizations, and once you get into there, how we are going to manage it within that system. Okay.
Okay. Is fault tolerant or something like that? Fault tolerance.
Come again, please.
Fault tolerance.
Okay. Yeah. Yes. Yeah. So these are all some of the challenges that we are facing. So because of these variations, sometimes we may not be knowing whether those changes or variations in those tolerances are primarily because of the real process issue, or is it because of a change or some sabotage or some modifications that people have made in the process parameters or in the entire process chain. So that is a real challenge at this point the industry is facing.
Because most of our all applications are online. Take railways reservation, air reservation. Even a server is down for 10-15 minutes. Public is very much, we get a lot of calls and the mails. You know that actually, how much important.
Yeah.
Whether it be a physical. Thank you very much, Mr. Sharif. Thank you.
Thank you so much for bringing that up.
Okay.
So any other questions? I know that this is a little different from what you guys were discussing previously. I think most of the discussions were focused on IT security, and this is a little extended beyond IT security because in manufacturing field now it's all about data. It's all about handling, managing the data. Apart from that, we also need to manage all other things which are coming from the machines. It's not the data that is coming from external. It is also the data that is generated within these machines and how this data is going to get processed and how this data is going to handled and managed and manipulated by different elements within the entire system.
Dr. Khalsa, hello, good evening, sir. Sir, thank you for a wonderful session. Actually, for this past 5 days, including today, so 6 days, we have been seeing so many classes. So most of them, like you said, sir, it's related to text data kind of thing. But this class is entirely different because it's related to physical things. So my question, still I know that, but when you are going through classes, in my mind different scenarios, seeing in different movies related to AI, machine, etc. So in your experience, do you ever this kind of threats in real life? What are the most threats you face within the system? I mean, for like you said, sir, in that malware attack, etc. We know that comes through email or phishing or a kind of this attack malware. Like you have to click the link, then it will be hiding obscure files. So so and so. But in movies, like in future movies, like they are showing like machine got AI intelligence, then they are seeing humanity as a threat kind of thing. So I know that is silly, but have you ever faced in real experience some kind of error by this machine?
Yes. So there is something like called interoperability. When we use multiple machines in this in the system, the cyber physical system, interoperability is a big issue. So when we send a file over to a machine, there is a possibility that the machine might not read that file in the intended way, in the proper way. Sometimes what happens is that these files can be taken away by someone, and then they can make modifications and create an equivalent or similar part that forfeits the IP of that particular design. For example, there was a recent callback from Honda. So Honda bikes, they have a speedometer. So that speedometer, people got the design and they started printing externally and saying that it is Honda itself, or it's Honda's part. So basically it is an IP thread. It is not from Honda, but those digital files are available in the internet. People can take those digital files and make some small modifications and produce parts as if it is produced by Honda. So counterfeiting is an important again threat through these mechanisms. So previously, when these files were not in the internet, nobody have access to it. But when it comes to digital manufacturing and advanced manufacturing, we have all these files available in the internet. If you want, you can get it through malicious ways. And we have seen this kind of things a lot. That is counterfeiting of the parts by forging these designs from different organizations. So that's one experience that we really have.
Okay, sir. Thank you. Thanks.
Other questions? Because I know this is a different topic, but still I want to bring this up. As I said, we don't have enough standards. Since we are a standard organization, we are also trying to get into developing some standards related to this topic. But it's an important topic at this point.
But sir, I think it's going to be the future. I think so. And thank you for your wonderful class.
Thank you.
Any more queries? Okay. Good evening all. Thus, we come to the end of our last session on the 6-day adult faculty development program on securing the future, cybersecurity, forensics, and the world of blockchain. On behalf of the Department of Computer Applications, MES College Maramballi, I extend our sincere gratitude to Dr. Khalid Rafi for his insightful session on physical cybersecurity in advanced manufacturing. Till now, in this FDP, we have been discussing topics related to cybersecurity, blockchain, and securing digital systems. In this session, Sir helped us understand how security can be ensured for physical systems, specifically in the context of advanced manufacturing and cyber physical systems. Sir's lecture provided a clear understanding of advanced manufacturing and CPS, including the evolution from the Industry 4.0 to Industry 5.0, highlighting key aspects such as human centricity, sustainability, and seamless machine-to-machine communication. Your explanation of cyber physical system components, the integration of IT and OT, and the layered architecture spanning OT, control, edge, and enterprise levels provided us with a strong technical foundation. We also gained valuable insights into threats, vulnerabilities, real-world incidents, risk assessment, threat modeling, control mechanisms, and incident response with the context of advanced manufacturing. We are truly grateful to you, sir, for sharing your expertise with us and for helping us appreciate how security, governance, and workforce development shape the future of manufacturing in the Industry 5.0 era. Thank you, sir. Thank you more. Thank you once again. Thank you all.
Thank you so much. Bye-bye.
Over to you, Bismil.
Thank you, Celine ma'am. Hope I'm audible.
Yes, you are.
Just a second. Hope my screen is visible.
No, ma'am.
No, ma'am, not
Sorry,
visible.
Sorry, just a moment. Hope now it's visible.
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am,
Yes.
visible. Okay, thank you. So, good evening, everyone. We are now officially moving into the validatory function of our 6-day online adult faculty development program on securing the future, cybersecurity, forensics, and the world of blockchain, organized by the Department of Computer Applications, MES College Maramballi. Over the past 6 days, this online program has provided us with an enriching journey into the world of cybersecurity, offering deep insights, engaging discussions, and valuable perspectives. To commence this validatory section, may I invite our esteemed head of the department, Department of Computer Application, MES College Maramballi, Dr. Joseph Darrell KS, to deliver the address. Sir, please. Dr. Darrell, sir, hope you are there.
Am I audible? No?
Yeah. Audible, sir. Audible.
Thank you, Bismil. A very warm and pleasant evening to all. Our esteemed principal and the convener of this FTP, Professor Dr. Mansoor Ali PP, my dedicated colleagues, coordinators of this program, Dr. Bismil V. Sharif, Ms. Celine M. and Dr. Jasur MP, our esteemed resource persons who shared their profound knowledge, members of the organizing committee, and a very reason we all are here gathered today, our distinguished participants. As a head of Department of Computer Application at MES College, it is a moment of immense pride and gratification to stand before you at the conclusion of this highly successful 6-day AICT Adult Faculty Development Program on securing the future's cybersecurity, forensics, and the world of blockchain. When we capitalized this FTP, our vision was to create a platform for deep, meaningful learning in areas that are not just current, but critical to our digital future. Today, seeming the culmination of this effort and the enthusiastic, more than 300 participants across the country, I can confidently say that our department has successfully contributed to this vision. Our deepest gratitude goes to our principal, Dr. Mansoor Ali PP. Sir, your leadership as convener and your constant encouragement were the bedrock upon which this program was built. Your guidance ensured we aimed for excellence and achieved it. We are also profoundly thankful to AICT and Adult Academy for this incredible initiative and empower faculty and fosters a culture of continuous learning. A special word of thanks to our distinguished resource persons. Your sessions were enlightening, bridging the crucial gap between academic theory and real-world application. Their real-world insights, hands-on demonstration, and willingness to engage with participants made this FTP truly experiential. You have truly enriched this FTP. To our 300 and more participants, your active participation, your insightful questions, even in an online mode, and your unwavering commitment over these 6 days has been the true highlights. You are the torchbearers who is now carry this knowledge back to your institution and inspire countless students. The success of this FTP is a direct reflection of your engagement. I must place on record of my heartfelt appreciation to my own team, the coordinators, Dr. Bismin, Ms. Selin, and Dr. Jasser, has been the pillars of this FTP, working tirelessly from the planning to execution. To the entire organizing committee and my faculty colleagues in the Department of Computer Application, thank you for your seamless teamwork and dedication. As we conclude, let us remember that this valedictory function is not an end. It makes the beginning of a new chapter where we apply what we have learned to innovate, educate, and build on a more secure and resilient digital world. With these words, on behalf of Department of Computer Application, thank you once again for your invaluable presence and contribution. Thank you.
Thank you very much, sir, for your great words. Hope I'm audible.
Yes, you are.
Okay, thank you. We now open the floor to our esteemed participants whose reflections will add true meaning to this valedictory session. May I kindly invite you to share your feedback on the 6-day online journey. Anyone from the participant side can share their remarks about the 6-day journey.
This is Naushad Ali.
Yes, sir, please.
I am audible.
Yeah, audible, sir.
See, good teamwork of MES College, Marepalli, Kerala. It means excellent resource persons means for me it is excellent. For me, your FDP is congratulations, your teamwork and excellent FDP. Thank you so much.
Thank you so much, Naushad sir. And we also take this moment to express our sincere thanks to you also, because you are an active listener and an active participant in all these 6 days. Thank you so much, sir, from our end also.
Thank you.
Yes, ma'am, please.
Am I audible?
Yeah, audible, ma'am.
I'm myself Rinku Sharma. I'm from SVKM Institute of Technology, Dhule, Maharashtra. I'm really very thankful and be the part of such a innovative and all excellent speakers for having the session. And the practical approach, I really like the practical approach all of the speakers who have given here. And it was really very informative session, ma'am, really.
Hello.
Thank you so much from my side.
Hello.
Am I
Hello?
audible, ma'am?
Yeah.
Yes,
Yeah.
yes.
Thank you, Rinku Sharma, ma'am, for your thoughtful feedback. It really adds value to our program. Thank you.
Hello.
Most welcome.
Am I audible?
Yeah, audible, ma'am. Audible.
Yeah. Myself, Professor Snehal Velkhude. I am from MIT ADT University, Pune. Am I audible, ma'am?
Yes, ma'am. Audible.
Yes.
Yeah, I feel truly privileged to participate in this FDP, that is Securing the Future Cybersecurity Forensic and World Blockchain, which is organized by the Computer Department of MES College, Marapalli, from 22nd to 27th September. These 6 days were offered in-depth perspectives on contemporary topics in cybersecurity, digital forensics, and blockchain. I was aware about cybersecurity, but the things about digital forensics and the blockchain were new to me, and I had the practical experience in the lectures, and that had helped me to update my knowledge and the teaching methodology, especially to integrate these cutting edge topics into my curriculum. So I especially sincerely thank to AICT Atal Academy and MES College of Marapalli for organizing such well-structured event, and I want to look ahead for the upcoming events also. Thank you all the team members and ma'am.
Hello.
Thank you, Professor Snehal, ma'am. Thank you for your kind words.
I am Banaja Basinratha from Baleswar College of Engineering and Technology, Odisha. The FDP on securing the future, cyber security forensic and world of blockchain. The program not only defended my theoretical knowledge, but also emphasized the practical applications, and also this helped my future research work. So I heartfelt thanks all the organizing staffs and college. Thank you all.
Madam, good evening.
Thank you, Professor Banaja, ma'am.
Madam,
Thank you for your words.
Good evening. Hello.
Yes, Ganapati sir.
Yes, I am Dr. Ganapati, professor from Dr. NGR University, Chennai. Definitely, madam, what your HOD, Dr. Joseph, told is 100% true. The thing which you organized, the Department of Computer Applications, MES College, Marampalli, on cyber security, forensics, and the world of blockchain, definitely we are going to take into the students, MTech, BTech students, which here around 1,800 students are studying actually here. All are in cyber security only, maximum, all the papers are on cyber security. Definitely we will update. My advice for your people is better you bring more industry people, because academic is good, no doubt about it. One thing I want to say, academic is theoretically we may be strong, but practical approach, whether in data center or e-governance or e-commerce applications, we have to know what exactly happening at the panic hour, penetration test or that thing, what we have to immediately do that. So that is the thing actually. But anyway, most of the people you have covered, particularly I want to say very good, enjoyed the Dr. S. Jay Ganesh class and Dr. Mahalingam PR. Our class very much useful and really more practical oriented. All other process class is also very nice actually. And I'm just thankful to AICTE et al. Because I am having industry experience of 38 years. After retirement, I joined as a professor. So I want to just give my service to the people actually, to the students. That's the thing I came. Like Joseph sir told, is 100% right. We will take to the students and bring the knowledge to them. Thank you very much, all the organizers, sir. Your coordinator for this particular program. I know that how much difficult organizing this from start to final execution. Thank you, everyone. Kudos to all your team, entire team. Thank you very much. Thank you very much, sir. Please.
Thank you, Ganesh sir.
Thank you very much, Professor Ganapathy, sir. Thanks for your valuable suggestions also. If any other participants would like to share the reflections, you are most welcome to do so.
May I go forward, ma'am?
Yeah, sure, sir.
Yeah, ma'am. I'm very much thankful to MES College Manampally for conducting this FD program. I really enjoyed the insights that were given on the cybersecurity and forensics. Cybersecurity we teach to the students as a different way, but what we learned about forensics and cybersecurity is something that was more of a thing that the real world people do. So that was very nice, and the experts were really very knowledgeable, and they are full of knowledge that they can share with us. So I'm very much thankful to them. Especially my area of interest was towards 2 or 3 sessions, but I really like Dr. Arin's Jose sir and Dr. Jay Ganesh sir. So those were the sessions I really enjoyed. Okay, and getting the professors from the same college and they knowing which day what content was covered was really very much nice and nicely arranged. So thank you very much to your department and to your college, sir. Thank you, ma'am.
Thank you, Professor Sejasvi Gupta, sir. And
Ma'am, test link, ma'am.
yeah, that will be shared shortly in the chat box. Yeah. Okay, if no more comments from the participants, I think we can conclude this session. So I request everyone to please turn on your camera so that we can take a pic as a memorable moment for the last 6-day journey. I request everyone to please turn your camera. Salim ma'am, I hope you have captured the screenshot. Thank you. Thank you. So now we are moving to the official concluding of this 6-day journey. I would like to extend our heartfelt gratitude to all the distinguished resource persons who shared their expertise and I'm sorry, I was actually a little bit trouble in logging. I'm sorry for that. Yeah, I would like to extend our heartfelt gratitude to all the distinguished resource persons who shared their expertise and experiences with us. Their insightful sessions on topics have equipped us with practical knowledge that will help shape the future of our classrooms and research initiatives. On behalf of all participants and on behalf of the entire organizing team of this FDP, I would like to take this opportunity to thank all the esteemed resource persons for the invaluable contributions. Your dedication, insightful sessions, and willingness to share your experience have made this program truly meaningful and impactful for every one of us. Next, I would like to extend my heartfelt appreciation to each participant for your active involvement, curiosity, and commitment throughout these 6 days. Your questions, reflections, and enthusiastic engagement have greatly enriched this program. It is your contribution that transferred this FDP from a set of sessions into a vibrant learning experience, creating bonds and exchanges that will surely continue beyond this platform. On behalf of the entire organizing committee, let me take this moment to thank each and every esteemed participants for your active involvement and enthusiastic participation throughout this program. Thank you, dear participants. Let me take a moment to sincerely thank AICT's Teaching and Learning Academy, ADEL, for approving our proposal and giving us the invaluable opportunity to host this faculty development program. Our heartfelt thanks goes to the College Management Committee for their constant support and encouragement. A special word of gratitude to our respected principal, Professor Dr. Mansoor Ali PP, for his motivation and valuable guidance throughout this journey. Next, I would like to express my deep appreciation to our head, Dr. Joseph Derrick KS, Head, Department of Computer Application, MES College Marampally, for the timely cooperation, guidance, and wholehearted support that made this program possible. We also extend our sincere thanks to our Vice Principal, Dr. Jasmine Ma'am, IQAC Coordinator, Dr. Jazina Ma'am, for their encouragement and support, which have greatly contributed to the success of this FDP. A warm note to thanks to the entire faculty fraternity of the Department of Computer Application, MES College Marampally, for their continuous encouragement and support. I'm especially grateful to Ms. Celine M. and Dr. Jasir MP for their valuable guidance and dedicated support in coordinating each and every single aspects of this FTP, and also for the valuable guidance and efforts in ensuring the smooth execution of the program. As we conclude this transformative 6-day journey on securing the future, cybersecurity, digital forensics, and the world of blockchain, may the knowledge, skills, and insight we have gained empower you to safeguard digital spaces. Let's take what we have learned and continue shaping a secure, innovative, and robust digital future. Thank you so much. Dear participants, the assessment link has been posted in the chat and will remain live until 8:30 p.m. Kindly ensure that you complete it within this time. Celine ma'am, please post, I hope you will post the assessment test link in the chat.
1 minute, ma'am.
Okay. Yeah, please wait. The link is actually sharing.
Ma'am,
It's actually,
excuse me, ma'am.
Yeah, please.
Ma'am, what about the reflection report?
Reflection report, we have extended the time till tomorrow 2 p.m.
Okay.
You need to download the format, do your reflections, make it PDF.
Where is the reflection report format?
Yeah, it's actually shared in the group, ma'am. Anyway, we will repost it once again for your quick reference.
Okay.
So kindly download it and do what all things you wanted to add, and kindly save it in PDF format and upload in the form provided. The form link also will be shared once again.
Okay. And what is the timeline for submitting the reflection report?
It's tomorrow 2 p.m., ma'am.
Okay, ma'am. Thank you.
Ma'am, from where will you get the test link?
Test link will be posted now itself in the chat link.
It is posted in the chat.
Yeah, you can refer it from there. The chat link, the test link is posted in the chat. We have 25 objective type questions is included in this assessment test.
Excuse me, ma'am, this is Professor Snehal.
Yeah.
Ma'am, apart from the test assessment, we have to give any other assessment on the Atal portal also?
Not any assessment, the test link, after this test, we will update the marks of each candidate or each participants in the adult portal. But after that, you have to submit a feedback.
From the Atal portal?
Yeah.
Okay, ma'am.
That will be live only after entering the test marks. So we will probably complete the other formalities from our end in the adult portal by tomorrow or the day after tomorrow itself. Then once it is over, we will let you know through the WhatsApp group. Then you can log in and submit your adult feedback and download the certificate.
Okay, ma'am. Thank you for the information.
Good evening, ma'am.
Yeah.
Time duration for this test?
Yeah, it's 8:30, ma'am. We have completed within the time. We have only 25 MCQs.
Okay, ma'am. Thank you.
Good evening, madam.
Yeah, good evening.
Ma'am, will you share this test link in the WhatsApp group?
No. It's actually posted in our Google Meet chat, sir.
In chat only.
Yeah.
Fine.
There only we can actually chart this test link. You can access it from the.
So there is an option for the test in that this Atal login also.
No. Actually, on the previous time when we do like that, we got some many participants got some error and got stuck with this the way. So this time we actually decided to go for the Google form and update the marks by the coordinators in the test portal. So in the adult portal.
What is the ending time for the test is?
Yeah, now it's 8:30, ma'am. 8:30, sir. You can
Okay,
take the
fine.
test till 8:30. We have only
Thank you.
25 MCQs. So
Excuse me, ma'am.
Thank
yeah.
Ma'am, this side Vikas, Assistant Professor Vikas Dhandwani from Shriram Institute of Science and Technology, Jabalpur. Actually,
Okay,
ma'am,
sir.
I did the one mistake, ma'am. Actually, in WhatsApp group, I have downloaded the PDF reflection journal format and the file which I made, na ma'am, after filling all the details, both the file by mistake having the same name. So I used the Google form link and submitted the file. So I'm not sure that whether I've submitted the blank format or the file which I personally prepared. So on your personal WhatsApp number, I have shared with you the correct one file, ma'am. If you don't
Yeah,
mind,
okay, sir.
you consider it,
Yeah,
ma'am.
sure. Noted. Noted. I will check my WhatsApp and the.
Okay, ma'am.
Yeah.
Okay. Thank you, ma'am. Thank you.
Okay.
Good evening, ma'am.
Yeah, good evening.
Yeah, ma'am. Does this reflection journal also carry mark for the final assessment test, ma'am?
Does this reflection journal? Can you repeat once again? Sorry.
Does this reflection journal carry marks for final assessment test?
No, ma'am. No, ma'am. The assessment mark will be purely taken from this 25 MCQs.
Okay. Thank you.
When that, what is the reflection journal to whom we need to send?
Sorry, sir.
Reflection journal to whom we need to send that?
Yeah, that's actually a Google form which is created from our end.
What is a primary reason law enforcement uses forensic images? Option A, to create system backups. Option B, to verify integrity for court evidence. Option C, to compress data. Option D, to automate system updates. Tell the answer. Which option?
Sir.
Just where we need to send that?
Sir, actually, we have shared a Google form in our WhatsApp group to upload this fill the reflection journal.
Once
Which
again, you
phase
can
of the cyber kill chain
Yeah,
follows
sure. We will.
creating a malicious payload? Option A,
Hello, am I audible, madam?
reconnaissance. Option B,
Excuse me.
weaponization.
Now, sir,
Delivery.
hope I'm audible.
Option D, exploitation. Tell the correct answer. Which option?
Hello.
Yeah, now, sir, we will again repost the link, reflection journal format, everything in the WhatsApp group.
Am I audible, madam?
Yeah, audible.
Behavioral analysis of malware includes
Hello.
monitoring.
Am I audible, ma'am?
Option A, Only read-only data sections. Option B.
One request from
Processes,
our side,
digital
please
entries, and
mute,
network
sir.
activity.
Yeah.
Hello.
Yeah, okay, please.
Hello, ma'am.
Yes, please.
There is a compulsion to upload the journal.
Yeah, that's actually, we got the instruction from the adult to upload this
Yes.
journal.
Okay.
Hello. Selina is there?
Yeah.
Ma'am. Okay, Bismillah. Ma'am, do we need to wait for anything if we have completed the
No,
assessment?
sir. If you have completed, you can leave, sir.
Okay, and the feedback form we need to fill on the Atal portal, correct?
Sorry.
We need to only fill the feedback form on the Atal portal.
Yeah. That will be live only after updating the test marks and attendance, sir. So after completing all those first from our end, I will inform in the group. Then only you need to
Okay.
log into the
No,
Adel
madam,
and
actually feedback form is on, madam. I filled the feedback form in the Atal.
yeah. Then it's fine, sir.
Feedback form I filled. Even
Yeah.
assessment test also, Google form I have filled actually, which you have given.
Okay, sir.
Feedback form is on only. Feedback form I filled actually. That is on.
Okay, sir.
Ma'am, this is Suganya,
Marks
ma'am.
will, Bismil madam, you will be
Yes.
entering the marks, sir.
Yeah. We will enter the marks.
You WhatsApp group, you just inform us, then we can
Yeah,
download the certificate.
sure. After the process from our end is over, we will inform through the WhatsApp group.
Thank you, madam. I'm just leaving.
Yeah. Thank you for your active participation in this all long 6-day journey, sir.
Yes, kind of you, madam. Kind of you.
Thank you, sir.
Ma'am, this is Suganya
Yes,
from
please.
United Institute of Technology. Ma'am, actually, the sessions was very good. We got a very informative sessions. And then without any interruptions, the session has been gone. Thank you for your organizing team and the coordinators who have been taken the class for us. We got us good information and regarding the cyber security because the booming technology nowadays. And as a professor, and I got some knowledge on how to teach for the students and where we have to give more knowledge to the students. Thank you, ma'am.
Thank you so much, Professor Suganya, ma'am. Thank you for your great words.
Ma'am, I need some one clarification. Ma'am, after the assessment has been, I need to take the screenshot and I have to put it in the group, ma'am.
No, it's not necessary because it's a Google form and we can track everything.
Because that's only some after the assessment has been done, you have to take. That's only I'm asking, ma'am.
Yeah. No issues, ma'am.
Okay. Thank you so much, ma'am.
Thank you.
Ma'am, shall we leave the session? As session is that till 7:30.
Yeah, till 7:30 the session will be live, but if you want, you can leave, ma'am.
Okay, sir. Okay, ma'am. Thank you so much.
Thank you.
Hello, Bismil ma'am. Am I audible?
Yes.
Ma'am, I'm done with the test. I want to know where to upload the reflection journal.
Yeah, now I have posted in the group regarding the form to upload this reflection journal, ma'am. Would be great if you can refer to the group. Just 1 minute.
WhatsApp group, right?
Yeah.
Okay.
Anyway, I will
Yeah,
repost
ma'am,
once
I
again
will
because we have got a lot of
Yeah,
screenshots
because
for
when
that.
yes. It will be great, ma'am, if you could post it again.
Yeah, I have. Yeah, I have reposted once again, ma'am. Please check.
Okay. Thank you, ma'am. I'll upload it. And it has to be in PDF form, right?
Good evening, ma'am.
Yes, good evening.
Ma'am, I took my assessment test, which is not mentioned in the Atel login, but I took it from my official mail ID. Is it okay, ma'am? Or should I redo the assessment test using my mail ID, which is given in the Atel login portal?
Ma'am, the mail ID you have registered have to be used.
Okay, okay, ma'am. So, should I redo the assessment test with using the mail ID which I have given in the Atel website?
Yeah.
Okay, okay.
Okay, ma'am.
Deepika ma'am. Am I audible? Deepika ma'am. Yeah, ma'am. Yeah, no need to take again the test in the adult portal. The marks which you gained in this MCQ that we have shared in the Google form will be updated in the adult portal. Hope it's clear. Okay, thank you. So, dear all, it has truly been an honor to host this program, and we look forward to welcoming you to future initiatives. Wishing you all continued success, growth, and a secure digital future. Thank you and goodbye.